Good morning, good afternoon, good night. Welcome to the 10th edition of Arduino Day. I'm here with
Fabio Violante. Hello everyone and welcome to the Arduino Day 2023.
So this is the 10th edition of Arduino Day that marks the 18th birthday of Arduino. So this means that Arduino can vote, maybe? No, not in every country, but, but one day machines will vote. But no, apart from this, thank you for being here. We are opening this event, which is going to be celebrated in hundreds of different locations around the world. But so what's going to happen today? So tell us a little bit.
So Massimo, we have a pretty packed agenda today because basically we are hosting a bunch of experiences and projects made with Arduino. We will have also people from the Arduino team that will talk about technology, about the fun we are having in the company, building this technology and keeping innovating as we have done for the last 18 years, as you just said. And of course, we'll take a little bit of time between me and you to talk about, a little bit of the more strategic directions we're taking as a company and all the great things that are in the oven right now to be ready in the future.
Okay, in the oven. Is it ready to, oh no, not, we have a couple of things that are coming out of the oven today.
Yeah.
But we don't want to say too much right now because so later on actually Fabio will sort of give you a more detailed keynote. And one of the things is that for the first time since 2019, we will have a physical Arduino event where people from Arduino are present. So we are going to be in Chicago at M-Hub. And so later on in this streaming, me and Fabio will reappear from Chicago. And, I hope you enjoy this Arduino Day.
Absolutely, Massimo. I think that it's also very interesting to be again in presence after several years, of the pandemic. So now it's going to be more kind of discussing with people in person, getting their feedback, getting their impressions, enjoying this day that at the end of the day is a celebration day.
It's a celebration of the community. At the end of the day, Arduino is built by an impressive community that has people, companies, fab labs, user groups, schools, all these kind of people put together, they make Arduino alongside us. So this is a big celebration. So enjoy the day and we will see you a little bit later.
Happy Arduino Day 2023.
Thank you. It's not vodka, it's water.
Hello, thanks Massimo and Fabio for that brief introduction. As they mentioned, they're actually going to be live in Chicago later on in the day, so they will be joining us towards the end of today's show. I'm Keith from the Arduino marketing team, and I'm here to co-host all of the interesting topics that we're going to run throughout the day, so I hope you enjoy it. We're going to start off with a couple of inspirational pieces from Arduino community members. Firstly, we'll have Mitch, who's going to show how he designed a MIDI controller for making music with a computer. And then we've got Agnieszka from TME, who are one of our distribution partners, who's going to show some of the great work they do with children across Africa and India, enabling them really to get access to technology and electronics and give everybody an equal opportunity. So really pleased to show those videos. I should mention that Arduino staff will be available online throughout today's show. So please feel free to ask away, ask any questions you might have about the projects you see, about the Arduino features, the Arduino products. We're here to help. Right, so without further ado, let's watch the first couple of videos. Enjoy.
Hi, my name is Mitch. I'm a creative technologist. I grew up hacking away on Arduino. I've been using it for about a decade for all sorts of different projects, and it actually helped me get employed. I bought my first Arduino when I was 16 because I kept reading about it on Hackaday and Engadget and all of the various DIY websites. So I decided to buy one for the first time, and I actually got into it because I'm a musician. I wanted to learn how to build my own instruments and connect them to my computer. Arduino was sort of an amazing unlock for my engineering potential, and teaching myself how to code and build interfaces that connect with various different pieces of software is what led me to the job I'm currently in. I'm a musician by trade and guitarist, so naturally I grew up taking things apart and reading Instructables tutorials for how to build all sorts of different things. And I got really into a piece of software called Ableton Live, which is a digital audio workstation for making all sorts of electronic music. What's interesting about Ableton, though, is you can actually build your own controllers for it. You can build your own software and plugins for it, and it's different from other pieces of music software. And that's where I realized that there's an entire industry based off of that, which is creative technology. So generally, we're part of a marketing department, and somebody who wants to do something really cool for a website, some sort of 3D or trade show activation, we'll come in and build some cool stuff for it. So if you like one-off experiences, if you like building cool artistic installations, Arduino is a fantastic platform for that. So here's the story. When I was a freshman in college, I was teaching myself how to code. And the best way I learned to do that was through music. So through a medium I had already learned, I was able to learn the technical side of things. And I would watch people in Ableton tutorials who had built things, and I realized that if I found a good button and I wanted it to make a sound in Ableton, then Arduino was the way to do that. I had no idea how that code worked. I just figured if they could do it, I could. So the summer of my freshman year, everyone was out partying or traveling. I was stuck in my dorm room trying to figure out how exactly do you hook up a button so it plays music in Ableton. Well, that's where this came along. Say hello to the elevator button drum machine. This is 16 steel spring-loaded buttons that are very satisfying to press, that you can hook up to any music software and make beats with. I designed and engineered a box. I found and sourced these elevator buttons, and then I hooked all of them up to an Arduino, which lives inside of this box. And this is where I learned, if I could hook one button up, then I could hook 16 of them up. And then each of these buttons have LEDs. So if you're doing your first blink tutorial, or you're doing your first button press tutorial, this is just 16 of them all in a row. And what was interesting is I had to learn what a multiplexer was. You don't want to run each one of these individually into your Arduino. So it's the challenge of coming up with a project like this and seeing it through. That's really the beauty of embarking on an engineering project or a personal project. You can use these tools with a goal in mind, and you don't have to know everything. The troubleshooting, the research, that's the fun of it. But actually seeing something through and being able to show it off to people and having something go from your head to something you can hold is the most satisfying thing in the world. And it's fantastic that we have tools like Arduino that actually let us get to do that. So I think making in general is a fantastic skill that forces you to use your hands to actually build something. It's very different from almost anything else you can do on a computer. And being able to tie physical hardware to a piece of software is a magical skill that can get you employed anywhere from your favorite car company to Disney. It's a lot of fun, and investing in these skills will definitely get you places. And I wanted to, I became a creative technologist, and that's because there's a bajillion different creative pieces of software that power all of these different verticals, and I became an interesting master of none and jack of all trades. So the best thing about finding a niche or your vertical is that engineering itself, buying an Arduino, that's not going to get you very far. You got to figure out why, right? What do you want to build? What's the point of using these tools? I am a music hacker at this point. I grew up playing guitar, so I've learned to build things like this, which is a tennis racket guitar that is fully electric. This is a piezo pickup. And this taught me woodworking. This taught me some basic pickups and electronics, figuring out how to actually plug this into a guitar amp. And that's the beauty of setting out on a project you've never been on before, is you get to learn and explore these ideas. That's what the research part of development is. Figuring out what you're actually going to build and then executing on that plan to build it. If you're a creative person just stepping into engineering, there's a lot you can do with Arduino. There are programs like Ableton, Touch Designer, Processing. I'll link to a couple of these below that can really show you how to connect an LED in the real world or a button in the real world to sound, to music, to lighting, to video, to any one of these very creative things. And you'll find that the more you explore and the more you're passionate about certain projects, and you've seen what other people do, you can take these things and package them up and modify them in whatever way you want. One of the things that a lot of people don't talk about is how well connected the technology ecosystem is. And there's various different ways to learn this stuff. If you go to your average coding tutorial, you're gonna X equals 1, X plus plus, or you're gonna build a calculator app, or you're gonna build your first website. A lot of that kind of didn't work out well for me. So I figured, how do I learn through music? I built a drum machine. Everyone has their interests, and you can apply these tools to almost anything. Specifically, I'd imagine a lot of people who are into Arduino are also into music making, video editing, game development, web, and just coding in general. All of these are incredibly employable skills. So if you're in middle school, if you're in high school, if you're in college, or if you're just starting out, at any age, the beauty of these tools is that if you learn these skills and you're able to teach yourself how to teach yourself, you will be employable very shortly, if this is the kind of thing you'd like to do. I am a pure example of somebody who's gone from hacking away in their bedroom all the way to hacking at a full-time job, pretty much. And it just took a combination of finding the right places, and obviously I've taken a creative route, but food. If you like food, there's ways to apply Arduino to food. If you like aviation, there's all sorts of different things, but really all I would suggest is find something you like, figure out a project within that, figure out how to apply these tools to get you there, and then see it through. It might take a couple $100. It might take 6 months or a year. You might have to work in between school and getting a job, but Arduino is a lot of fun. And it's taken me great places, so I'm excited to be part of the community. When I'm not at work working on cool stuff, I'm usually at home building all sorts of different musical projects, and you can find me on Instagram at MicroPython. So feel free to shoot me a message if you see something cool or you want to get in touch. Be happy to chat.
Hello, my name is Agnieszka Jankowska, and on behalf of TM Education family, I'd like to thank you for the opportunity of becoming a community speaker during this year's Arduino Day. Let me tell you in a couple of words what we do and who we are. TME Education is a program founded by Transfer Multisource Electronic, known as TME, a global distributor of electronic components based in Łódź, Poland. Our goal is to promote electronics and technology-related knowledge in regions where access to proper educational resources is limited. We set off for our journey in 2016 by establishing a collaboration with University of Technology and Science in Kumasi in Ghana. Since then, we've been providing training on electronics and Arduino programming together with our 40 ambassadors and tutors in 23 African countries and India. What are our focus areas? For example, collaboration with schools and institutions. Together we create labs and clubs, safe space where students can learn and acquire new skills. TME Education provides both equipment and teacher training. Why is teacher training so important? Because a teacher is a person a student turns to when he or she has a problem or needs inspiration. That's why we share our knowledge, our experience and some tips with the school staff so they can provide students with the best support. We partner up with different kinds of institutions of different levels, from primary schools through secondary schools to universities. We absolutely adore vocational schools. Why? Because these kind of institutions provide students with real-life skills that later on are vital to create their professional, sustainable future. We are all about inclusivity. Through working with various girls' schools and institutions that facilitate women's access to education, we would like to create a world where girls and boys can participate on labor market on the same terms. Moreover, we team up with various clubs, labs and hubs that provide education to all of those who for certain reasons cannot attend regular schooling. Thanks to having a group of local and proactive ambassadors and tutors, we are able to provide highly practical training sessions. Practice is a must. Of course, theory is required, however, when it comes to electronics and Arduino programming, you have to get your hands on experiments. That's why we keep our groups relatively small so everyone can get the chance to program, prototype and get the vocational skills. Providing interesting and practical workshops requires specific tools. In order to make our training sessions both fun and learning, we decided to create our own educational tools, and Arduino-based board is our favorite one. And here it is, our beloved educational board based on Arduino Uno, which is the heart of this device. And on the shield we have various components that make Arduino learning even more exciting and user-friendly experience. What we have here, we have an LCD display, we have push buttons, potentiometers of course, sensors, microphone, buzzers and many more. It's compact, easy to carry, actually quite hard to break and allows one to create from basic to intermediate projects. Of course, this board can be expanded and used for more advanced ideas as well. It has a relatively low entry threshold and one can learn both electronics and Arduino programming. As TME Education, we belong to various communities and Arduino community is the biggest of them. To be honest, Arduino Day is the most important event in our social calendar. We've been organizing it since 2018, back then in Malawi, Uganda, Tanzania and Egypt. This year, we are celebrating Arduino Day in 20 African countries and India. And at this very moment, our ambassadors and tutors are conducting workshops on Arduino, organizing challenges, competitions, and enhancing students' creativity. Speaking of which, creativity is the quality we cherish the most. It allows one to think beyond and become a community change maker. Through our program, we encourage our ambassadors, tutors, and students to use their knowledge to create solutions to real problems. Working with respect to local communities allows us to tailor them to their needs. Here are several Arduino-based projects that apply the acquired knowledge to creating change-making devices. Robot for kids with ASD from Eswatini, water purification system integrated with M-Pesa system from Kenya, and vending machine for sanitary pads from Tanzania. Wisely applied technology can be a tool to create a better reality for communities. Arduino opens up endless opportunities for creators and change makers. On this very special day, on behalf of TM Education family, I'd like to wish you all the best. Happy birthday, Arduino!
Thanks to Agnieszka and Mitch for those videos. If any of you have been following Arduino Day for the last few years, you probably recognize some of the TME ambassadors. They've won various Arduino awards in the past for the work they're doing in Africa. So keep up the great work, guys. Last November, we were really proud to announce that MicroPython had become part of the official Arduino ecosystem. So in a video following up, we've got Ubi, who's both a teacher of electronics, but also an Arduino engineer, who's going to show you how simple it is to use Arduino Lab for MicroPython with the Nano RP2040 Connect board. So that should be a very interesting piece. That will then be followed by a couple of videos. We've got Alessandra, who's a very passionate maker, musician, and teacher of electronics, to show you some of the great work she's done with Arduino, including an electronic replica of the Enigma machine, which is an amazing piece of kit. And then we've got Carlos. He's designed a robot to help children with autism spectrum disorder, or ASD, in their learning and social development. So a great piece of work to help with inclusivity. So please enjoy the videos.
Hello, welcome to Arduino Day 2023. I'm Ubi DeFeo and I'm here to talk to you about something that I'm pretty excited about. As you may know, Arduino has been on the forefront of teaching electronics and microcontroller to designers and makers for almost 20 years. It has changed many lives, including mine, and the fact that nowadays I work at Arduino and I bring my knowledge into the ecosystem makes me extremely proud of what I do. Over the past few years, you might have seen the presence of Python in the world of microcontrollers to become bigger and bigger. I've been keeping my eyes on it, and so has everyone at Arduino, for a few years. And I remember buying one of the first Pi boards from MicroPython in order to support the project, way before I joined Arduino. As a teacher of physical computing, I have over the years been teaching the classic Arduino using C++ and all the ecosystem of libraries, of boards, platform support, and so on. And it served me extremely well, to the point that when I joined the team, I knew a thing or two about teaching Arduino to students, mostly to interaction design students. And I thought it was extremely exciting to put your hands on the hardware, to, manipulate bits and write code that would end up on something tiny as this, and it would be useful to control motors, LEDs, sensors, and all, the things that we've come to learn and love over the years as interaction designers and physical computing students and teachers. Over the past few years, I have been more and more curious towards Python as a language, and I've had the chance to write some small programs with it, to analyze data, to make API calls and so on. And I found myself on this edge, what do I want to do? Do I want to keep teaching traditional Arduino to designers in 2021, or do I want to move to something that is more easily approachable? As you may know, the high performance that we can reach thanks to Arduino and C++ is unparalleled. We have a massive amount of microcontrollers and prototyping boards which are supported by the ecosystem. And MicroPython has been making its way into this world way more slowly than Arduino and C++ have over the years. But nonetheless, because I'm a curious individual, I wanted to bring it to my students. So I decided to make an experiment, and I used one of my favorite boards. It's the Arduino Nano RP2040 Connect, which is based on the Raspberry Pi RP2040 microcontroller, and it runs MicroPython extremely well. inside Arduino, we have been putting a lot of effort into the MicroPython world, specifically with OpenMV, which is a MicroPython version that has a lot of additional libraries and abilities to do machine learning and artificial intelligence. For beginners, this is not very easy to approach. It's kind of scary if you have never touched a microcontroller or if you have never written a line of code to be told use this board and use something for machine vision or artificial intelligence or machine learning. You want to start slowly. You want to take a stepping stone into this world, and Python is an extremely beautiful language. So inside Arduino, we decided to run a few experiments, and we looked at what was available out there in matter of code editors. Can we get something that is as simple as the original Arduino, what actually brought microcontrollers into the hands of everyone, pretty much. So we started looking at side projects, editors. We looked into the usual suspects. We looked at Thonny, we looked at Mu, and we wanted something that was simpler. So we decided to take the road which we know best. Start from something simple and develop something that is approachable. And we came up with Arduino Lab for MicroPython. This is an extremely simple editor which reminds us of the original Arduino editors, just with a fresher interface. We worked in collaboration with the original creator of this editor, and we brought him inside Arduino. So this is internally developed, and it's one of our labs project. If you check out labs.arduino.cc, you will find this editor and a couple more projects. We internally bring these labs to the open every now and then. As soon as we have something interesting, something that is cute, and it's kind of playful, but can be useful, we bring it to the public. So this is what happened with Arduino Lab for MicroPython. This editor is extremely simple. It allows you to connect to a board, and every board which runs MicroPython is supported. We wanted to bring something which would be more approachable, more immediate. And MicroPython is a small Python interpreter, a subset of Python. So we can essentially just write code directly on the board. You interact with these boards connecting to a serial port which exposes the REPL, read, evaluate, print, loop. This interface is like a terminal. You can simply write things into it, and the code that you write is executed on the board and evaluated, and its result is returned into the terminal. Let's try this. 1 + 2. This code is running real time on the board. It's executed and it gives us something. So print hello Arduino, and this one is printed. And we can interact with the microcontroller. This is a demo setup which I'm going to use in today's configuration. Let's look at it. It's super simple. We have a servo motor attached, an LED ring, an LED matrix, and a display. Let's blink an LED. If I want to blink an LED, I have access to the pins of the board as long as I import the object that can control the pins. So from machine, which is a library that handles everything that is hardware, import pin. I can now define a variable named LED, and I can say this LED is pin number 6, and it's an output pin. Now, this code has been registered by my interpreter, which means that I can just ask my MicroPython board, what's LED? and it's going to tell me that LED is a pin, and it's pin number 6, and its mode is out, so I can turn it on and off. I want you to take a look at this corner of the board. This is where the onboard LED, which we know from Arduino as LED built-in, is connected to. So if I type LED dot on, this LED will turn on. LED dot off, this LED will turn off. And I have a facility for toggling the LED. So anytime I toggle, I can basically turn it on and off. So on if it was off, and off if it was on. Now let's clear this terminal and do something else. I have turned on and off an LED, so the same way as we can write a digital value to the pin, we can read its value if we're using a button. At this moment I don't have any buttons connected, but I want to show you something. I want to show you how to use a library. I have some examples here. I can read from here, and I have this example for Grove LCD. So from machine, I import I2C. I2C is a communication protocol for microcontrollers, and I import pin. And I import this library, which is on my board as some supporting code, and it's called I2C LCD. I define an I2C bus, and I say this I2C bus is my first bus, and it's connected here. I can define a variable called display, and this display is an RGB display because that's what it is connected. This LCD display allows me to have a backlight with a colored LED. I am going to just run this program, and this program will write Arduino Day 2023 on the display, will move to the second line, and will write MicroPython. And then it will set the color to a light blue/teal. Run it, and that's where my code happens. The beauty of this is that this code is executed, but I can interact with the board because all of this code has created some variables in the microcontroller memory. If I type display, I can access this screen. So I can say display.clear, and the display is clear, and I can say display.write hello world, and I can set the background color of the display. So display.color, and I want to set some purple, so I'll do 200, 0, 200, I made a typo, and now it's a light purple. And I can move to the second line, so first column, second line, display dot write Arduino 2023. I can also turn off the background, so display dot color 000. Okay, this is how simple it is. Now I have other examples. I can use the LED ring. Most of us know these LED rings as NeoPixels, but NeoPixels is just a brand name. They're addressable LEDs. If I run this code, I import the library, and then I import the pin, and I define ring as a NeoPixel object. I'm going to run this code, nothing has happened, but I can essentially type some code to make this happen. And I'm going to type it here. I'm going to clear the terminal, and I'm going to write ring. So the machine knows what ring is. I can say ring, the first pixel will be equal to red. 25500 is red, and then I can type ring.write, and the first LED will be red. Now I can write the second LED to be purple. Red, no green, and blue will give me purple. Ring.write will commit the changes and the second LED will be purple. Now let's look at the third thing that we have attached there, an LED matrix. I already wrote some code for this one. It's here. This code will basically import I2C because this is a matrix which works on I2C, and it will create the object, and then I will be able to plot the LEDs, so turn them on or off, and to update the matrix. So this LED will now turn on and be red. Looks yellow, but it's just a camera artifact. What I can do now, because all this code is in the memory, I can say matrix dot plot 0, 0, and then matrix dot draw, and the first LED, which is at position 0, 0, will be turned on. I can do a lot more in MicroPython. I can leverage the sensors on board, the microphone, the color sensor, gesture sensor. There are plenty of libraries developed for MicroPython. Of course, we continue to strive to make this world better for people who want to learn MicroPython. Arduino actively contributes to the MicroPython upstream, so on a daily basis we issue PRs, we have an extremely good relationship with the MicroPython Foundation, and we love MicroPython as a language. So we want to bring more and more libraries to you, and we want to bring better editing capabilities into Arduino editors. We really look forward to bringing more of this to you, but for now, just play with it. Download it from labs.arduino.cc, pick your Arduino board to run your code on. You can run it on every board that supports MicroPython. So go on, get your own adventure, and let us know what you do. Just talk about it and tell your friends. We really look forward to knowing what you're up to. Thank you so much, and enjoy the rest of the Arduino day. Bye.
Hi everyone, I am Alessandro De Vitis. I'm a physicist, a musician, a maker, and a teacher. I live in Latina, a city near Rome in Italy. We have sea, the mountains, and the lakes in the surrounding area. There are ancient Roman ruins too. I like traveling very much, and it was in 2010 in the United States that I discovered Arduino, and I bought my first kit. So I started to build robots because I love making robots. I participated in various editions of European Maker Faire in Rome and Maker Faire in Trieste. I won Lady Maker Prize at Trieste Maker Faire in 2020 with an electronic replica of the Enigma machine made with Arduino Mega. I had a special mention at the European Maker Faire Rome in 2021 for Smart Termin project made with Arduino Uno. I teach computer science at Istituto Tecnico Industriale Marconi in Latina and computer science education design at Sapienza University Rome, Computer Science School. In both courses, I use Arduino Uno because it's a very useful instrument for game-based learning and gamification. I organized with some colleagues Arduino Day 2017, Arduino Day 2018, Arduino Day 2021, and Arduino Day 2022 in my school. And now we are preparing Arduino Day 2023. At the moment, I'm speaking from my school. I am in my lab with my students while they are practicing with Arduino Uno kits. Practice in class is fundamental. Students learn how to do and how to collaborate. Working in groups or presenting projects is stimulating and important for self-esteem. We use Arduino Uno in our classes because it's an easy-to-use hardware and software system. Students realize interesting projects while they learn. They learn computer science and electronics with no efforts. They learn also the importance of teamwork. There are 3 pillars of game-based learning using Arduino Uno: cooperation, creativity, and competition. Cooperation, because group members must work together. Cooperation is important also between the various groups. Creativity, because every group has to think and realize their own project. Competition is the final step. The projects enter the competition on Arduino Day, and they work at their best to win. Here, there are my projects I mentioned before: the Enigma replica and the smart terramin that I realized with my friend Achille De Santis. The Enigma replica is made with an Arduino Mega. It's a replica of the M4 Enigma. The original one has 4 rotors and fully mechanical. This one has software, a lot of lines, and the 4 rotors are replaced by 4 17-segment displays. I decided to make an Enigma replica because I loved the Enigma machine from when I was a child. I think it's the most beautiful crypto machine. So, because it's not possible to buy one, I decided to make one by myself. It took a lot of time to finish it. First, because we have only weekends to work on it. Second, because, as you see, there are thousands of wires to solve and check. This other one is the smart terramin. It's a terramin made with Arduino Uno, and it's possible to control volume, pitch, and timbre. We decided to build it because it's a fascinating instrument. It's the only one played without physical contact. Instead of by thing, I prefer to make by myself. It's more exciting. It's easier to realize than the Enigma machine. We built it in just one summer. How does the terramin work? The terraminist stands in front of the instrument and moves their hand in the proximity of the 2 metal antennas. The distance from one antenna determines frequency, the pitch. And the distance from the antenna makes the pitch higher or lower. The other one controls the volume. Higher the notes are played by moving the hand closer to the pitch. Louder notes are played by moving the hand away from the volume antenna. The antennas act as plate of capacitors. The performance arms act as the ground plate of a variable capacitor in a circuit, which is part of the oscillator and determines its frequency. To control the volume, the former other end acts as the ground plate of another variable capacitor. As in a tone circuit, the distance between the performance hand and the volume control antenna determines the capacitance. Now we are working on another robot from Doctor Who TV series. After making the first 2, we are making the robot dog called Key9, and we hope to present it at next Maker Faire. Here are my students working with their Arduino kits and are preparing for Arduino Day 2023. Thank you.
Hi everybody, I'm Carlos Alberto Arenados Ibarra, an undergraduate student of electronic engineering at Pontificia Universidad Católica del Perú. I'm interested in the development of social robots, data science, and artificial intelligence. I like to carry out a project that seeks a social benefits and an improvement on my society. Along these lines, I developed a social robot together with Adrian Woman, William Mesa, and Roberto Reis. The project's name is Kogi, which confronts the Latin word cogitarium. Kogi is a robot designed to address the developmental issues and lack of attention faced by children with autism spectrum disorder. Kogi is expected to be used in schools and homes to promote children's cognitive and social learning, with its affordable cost and easy transportability. Kogi is a valuable tool for helping children with ASD and supports them at all times. The robot engages in reciprocal conversation with the child through a simple and direct language that is easy to understand. Kogi applies the concept of human-robot interaction through the use of its size, head movement, and mobile phone application. The robot's ability to express emotions through its size and head movements, as well as interact through the mobile phone applications, allows for a more natural and engaging experience for the user. We went through 6 design prototypes until we finally got to the final design. We can see the robot design was improved design after design prototype. It has an ultrasonic sensor on its smartphone stand which detects objects between the user and the robot. Its eyes can display different emotions depending on the situation, such as happiness or sadness, and the selection of colors has been chosen in such a way that they are characterized by being relaxing to help children feel comfort. The project has been carried out in such a way that is replicable and easy to understand. The pieces has been made by 3D printing and a development board known as the Arduino Mega is used. Additionally, the use of 3D printing technology permits for customization and flexibility in the design of Kogi, which can help to make it more effective and engaging for children with ASD. Kogi's portability is also a key factor in its affordability and effectiveness.
Hi, I'm Kogi, your partner with who you learn new things and have a lot of fun. Please, call a trusted senior to connect me. Let's talk. How are you? I'm worried to seeing you like this. I want to help. Let's play together. I heard this song and I want to show you.
The project consists of a motor for the movement of the head, 2 OLED screens to show the eyes, an ultrasonic sensor so that the robot is a suitable distance from the child, and finally a Bluetooth module for the Arduino Mega development board to communicate with the mobile application. The interactions carried out in the application will have a response from the robot that will be shown by the movement of the head, accompanied by facial expressions. Kogi is a robot that helps children learn and explore the world in a creative and engaging way. It acts as a supportive partner who cares about its users, and the aims of Kogi is to become a social robot with the ability to have personalized conversation with children based on their unique personalities and preference. And the team is also working to develop more dynamic conversations, features, and interactive toys to provide more opportunities to learn for children. Also, it's true, the electronic part used is not complex, the research behind it takes a long time, and the benefit for children with ASD is significant. If you are starting or are already working on a project, I recommend you not giving up. Many times, things didn't work out as we want. However, we must seek help because there is always someone who can support us. Likewise, I encourage you to develop a project since the path and the result is a unique experience. If you want to contact me, you can look for me on LinkedIn. Thanks for your attention.
Hi everyone, I'm Aurora and I'm from the marketing team as well. I'm going to be your next co-host. So the next project we're going to have a look at, I'm actually quite excited about because I have a really poor history of keeping plants alive, as you can see. And the next project is the Smart Terrarium, which is going to be presented by Pierluigi. He's an electronics engineer at Filo Connesso. After that, we have two unique projects that we're going to share with you. The first one is by Guilherme, and it's the interactive Arduino banner. Basically, the project is an interactive and engaging banner that will inform everyone about Arduino Day events, and it features a board connected to various sensors and touch-sensitive interfaces. The second project we're going to show you is the Decentralized Mechanisms by Ralph, and it's prototyping IoT sensors, which helps with like critical modern and digital infrastructure and paving the way to design new forms of water policy. So pretty cool, so stay tuned. Don't forget that you can also ask questions in the chat. We're welcome to any questions, and thanks for joining us and enjoy.
Hello everyone, my name is Pierluigi and I'm part of the Filo Connesso community. First of all, I want to thank Arduino for the invitation and for giving us this opportunity to talk about our latest project. Our latest project is called Terra, and it is a smart terrarium. Briefly, these are the topics that I will cover in this presentation. We start with the main feature of Terra, Terra for schools. I will show you the first prototype, Terra and Arduino, and with the final slide, our thanks and contact information. Terra was designed with three main features in mind. We wanted it to be smart, connected, and autonomous. Smart, because Terra is equipped with multiple sensors, including air and soil humidity sensors, temperature sensors, external humidity and temperature sensors, light level sensor, and CO2 sensor. With the acquisition of this data, Terra can implement various control algorithms and find the best formula for your ecosystem. Also is connected because Terra has a Wi-Fi connection that allows you to keep track of its operating status at all times. And finally, autonomous, because Terra has an automatic air recycling system to control the internal environment, but at the same time, it can isolate the entire ecosystem from the external environment. Also, the internal ecosystem can be illuminated by an automated artificial light source. And also, Terra has a small water tank to maintain the desired level of internal humidity. Terra can be an educational tool for schools. Thanks to its technology, students can learn interactively about plant life, ecosystem, and their importance to the environment. In this way, Terra can be used as an educational experience for schools, allowing students to learn through hands-on experience and data collection. In addition to traditional object-oriented programming, the student can also program their terrarium using a block-based programming language. We have built the first prototype of Terra, which you can see in the picture. This prototype covers 95% of all the features we have shown you in the previous slide. For example, we have not yet selected the CO2 sensors and also the external humidity and temperature sensor. From software side, we have already developed a library that allows us to start using Terra feature and start the first test of Terra. If you are here, you already know perfectly well the potential and the performance of the GigaR1 Wi-Fi. This new product from Arduino is perfect for the Terra project. A single board has made it possible to meet all of Terra's requirements. For example, having on the same board an USB in host mode, Wi-Fi connection, non-volatile external memory, various digital communication interfaces like I2C, SPA, UART, OneWire, many GPIO available, and the ability to use a real-time operating system like EmbedOS. Today, we have the first prototype, and our roadmap is to arrive at this year's Make and Fair Rome with a new prototype ready. This new prototype will have all the hardware we have shown you in the previous slide. A new mechanical design project looking for a stylish design product, and additionally, the cloud platform for managing Terra will be developed. We are at the end. Thank you for your attention, and thanks again for Arduino for the invitation. Filo Connexo is an Italian community present on several social media platforms, especially on YouTube, where you can see all the activities related on this project and others. If you have any question about Terra, do not hesitate to contact us. Ciao!
Hello everybody. We are here from Brazil, from FabLab Facens, to present our projects to the Arduino Day. I am Guilherme, this is Nicolas, and this is Lucas, and recording the camera is Anthony. We are the team responsible for this developing this project that I will go to present for you now. Our project for the Arduino Day is this banner. It's an interactive banner. We are at a university here, and we needed to inform the students about the Arduino Day and in March 25th. So we even have the t-shirt like I'm wearing now, but we need this panel outside for the students to interact with it. It was made using a laser cutter, an Arduino board, ultrasonic sensor, touch sensors, speakers, an MV3 module, and a power modulator. So how does it work? When somebody stands in front of the panel, it activates through the ultrasonic sensor, and the panel makes 3 questions. The first one is how the panel, if you want to know how the panel was made, and you can answer yes or no. The second question is, do you know what an Arduino is? And you can answer yes or no. And the third question is, if you want to know how to code the world. In case you answer yes, it will light up the QR code here, and when you scan it, it will send you to a form that you can subscribe to the Arduino Day. And you see our schedule for the day. We will have talks and workshops here at the Fab Lab. Now I will show you the panel working. Just to know, it will ask 3 questions. It will be in Portuguese because we are in Brazil. The text is speak through an AI, and I will answer the questions just for you to know how does it feel. So, if somebody stops in front of the panel,
quer saber como esse pôster foi feito?
If I want to know how the poster was made, I will answer yes.
Esse pôster foi desenvolvido pela equipe do Fab Lab Facens utilizando cortadora laser, a placa Arduino, sensores touch, módulo MP3, módulo Wi-Fi, sensor ultrassônico e alto-falante. Você sabe o que é um Arduino?
Well, the panel answers the question, telling how the panel was made, and if asks back if I want to if I know what is an Arduino. I will say I don't know what is an Arduino.
O Arduino é uma plataforma de prototipagem eletrônica que consiste em uma placa de circuito integrada e um ambiente de programação que permite controlar diferentes dispositivos eletrônicos. É amplamente utilizado em projetos de robótica, automação, IoT e outras aplicações em que é necessário interagir com o mundo físico de maneira personalizada e flexível. O Arduino é projetado para ser acessível a iniciantes e avançados, permitindo que os usuários criem projetos personalizados com hardware e software de código aberto. Quer saber como programar o mundo?
Basically, the panel answered me what an Arduino is and asks me if I want to know how to code the world or how to program the world. I will answer yes.
Acesse o site fablab.facens.br e faça sua inscrição ou escaneie o QR Code ao lado. Obrigado pela participação. Nos vemos no dia 25 de março, das 9 horas às 18 horas, no prédio C da Facens.
The panel asks me to type the website or to scan the QR code that sends me to forms where I can see our schedule for the Arduino Day and subscribe to the activities and says thank you. The banner resets itself after 60 seconds. If somebody activates it and doesn't answer, it will reset so another person can interact with it, and all the answers, yes or no, are recorded at the EEPROM memory of the Arduino, so we can get the answers back after a while when we plug the Arduino back to the computer. And that was our project. I hope you like it, and I'm happy to be part of Arduino Day in behalf of our whole team, and thank you very much.
Hi, my name is Ralph, and I have an Arduino project that I would like to share with you. So just a little bit about me. I'm a university graduate in agriculture economics, focused on water resources, and this has been my passion throughout all my degree. I think water resources is one of the most underappreciated policies in agriculture today. But it is gaining more and more traction, and there is more focus on how to better manage water, especially on a large-scale river basin. One of the things that I find is the lack of data availability. So you want to be able to have data that's fast-paced, that you can see water flow, you can see water quality data at a specific area in a river, and there's some other interesting theory out there that could potentially be the future of water management systems. And that is, for example, to create a water trading system on a river, which allows agribusiness to sell water to his or her neighbor with a smart contract or to enforce agreed water volumes. Essentially, we're talking about water conflicts and how to better share water between people that are located on a river. But to do that, you need a lot of sensors. And you can imagine that there are 3 agribusinesses here located on a river. And on the river here, you have a strain of sensors that are checking how much water there is. But you also need to have sensors placed on every agribusiness to make sure you know how much water has been taken from each sort of agent or each property. So I started to say, how do you actually create these sensors from the ground up? And I used Arduino to create this small type of sensors. And I'm very new to this game, so I just learned how to have a microcontroller, what's a sensor. I learned a bit of coding, Arduino, sketches. I learned a little bit about ChatGPT as well. And then I also want to make sure I learn about blockchains. How do you put something on a Google Sheets that turns it into an API that can connect with Chainlink, for example. And it turns out that, as I mentioned before, you need more sensors in agriculture. I think it's quite obvious to detect environmental aspect, which can significantly improve, create new forms of water policy. But yeah, I found out that it's actually a lot more complicated than I just realized. There's a tremendous amount of things happening, from hardware to software to how to compile it, and it's already like write script to send it to an API. All that was a lot for me. So I turned to the Arduino platform as learning more about it, and it's a great environment. Hands down to the people at Arduino for teaching people, not just children but also young adults like myself, to learn about what it's like to program and what are the mechanisms behind it. And so I discovered that you have the old ways of designing projects. It is, you should have schematics, circuit boards, sensors, source code, prototyping, minimal viable products, and then you go into manufacturing. But these new ways is sort of coming into play now, where you just need to have a core understanding, and then you use ChatGPT or the new GPT-4. Then you ask that sort of like, what's the most suitable sensors that are available? And then you make a code validation and you make sure you test it. And so I did that. I asked ChatGPT, can you create a code for me on a Wemos D1 Mini? You just want to connect it to a YFB1 sensor to pin D7. And then I want you to create two columns. Create a column with flow rate, liters a minute, and volume on the second column. And then you should connect it to my Wi-Fi network, and then connect that to a Google spreadsheet. And here's the spreadsheet ID. And then I want you to tell me what's going on. So you should tell me all what's happening in the serial monitor display. And I want to see exactly what's going on behind the lines. And it does that. So basically, a lot of the work that has been done to learn the basics of programming, to learn the basics of how to create sensors, all of that really is now a question of what's your creativity, can you define the task, and are you able to put it all together and understand where these pins need to go. And the results of this project is that, sort of like, even like sort of a promotion now to ChatGPT, but literally it's faster work processes to better integrate IoT devices with water policy. And that can in itself change the future of agriculture. And particularly when it comes to water policies or policies in general and technology. And yeah, I think all of this, the Arduino environment and the Arduino community, combined with OpenAI and the implementation aspects, which is where do we actually need to create something new. I think we're seeing a very interesting future ahead of us. So if you want to know more about this, the project name is called Decentralized Mechanisms. My name is Ralph Peterson, so you can always send me an email as well. I prefer that. If you have any questions, or if you think that this could be something that you would be interested to collaborate with, or someone that you think could be interested to collaborate, you can also find me on LinkedIn, and I have my LinkedIn address here. Yeah, thank you so much, and I wish you a pleasant Arduino week.
Hey everybody, we're back. So for our next videos, our next one is going to be everything about the Arduino Cloud, what's new, and all the features that are coming out. It's going to be presented by our product manager for the Arduino Cloud, David. So everything that's excitingly coming out with the Arduino Cloud and the things that are on the horizon, don't forget that there is an Arduino Cloud plan suitable for everyone. So you can even use it from your mobile phone. It's that easy. And don't forget, you can also try it for free. Everyone loves a freebie. The next project after that is going to be presented by Eliza, and this is a pretty cool project because it's named Girls Just Want to Have Fun, Functional Dolls That They Can Code. And what Eliza does is she teaches young girls how to code through different projects, and she allows girls as young as 5 years old to get into coding, and especially through this project, which are the Eliza dolls that use Arduino technology. So, ladies and gents, enjoy the next videos.
Hello everyone, my name is David Beamonte and I am Product Manager for the Arduino Cloud. It's a real pleasure and honor to be part of this Arduino Day and have the opportunity to speak about what's going on the Arduino Cloud. As you all know, Arduino is very well known because of the hardware, the boards, the kits, etc. But in this presentation, we are going to change the focus towards how we can manage, monitor and control that hardware. For those who might not know what the Arduino Cloud is, I will do a short introduction and then I will jump directly to present the latest news and features that we have introduced in the platform. At the end of the presentation, I will give you a sneak peek into the exciting future of the Arduino Cloud. Okay, so without further ado, let's begin with the presentation. And first, let's start introducing the Arduino Cloud. All of you are here because you are Arduino lovers. And that is because Arduino has made IoT and do-it-yourself simple and accessible for everybody. The Arduino Cloud shares the same goal. We want to keep it simple and accessible. Creating connected devices that can be managed from the cloud should be easy both for beginners and skilled users, and that's our main goal. That said, let's get started with the basics. The Arduino Cloud is a concept that identifies the whole platform. It's an all-in-one platform that can be used for development, deployment, and device monitoring and control. The platform has two main applications, the online web editor and the IoT Cloud. On the one hand, the web editor is the online alternative to the classic Arduino IDE. It is the easiest way to get started with Arduino programming. It is zero touch, as you don't have to install the application, bother with the application dependencies and configuration, or to install the libraries. On the other hand, the IoT Cloud is the application that enables you to manage and monitor your devices and their data. So, the web editor is the way you have to interact with the firmware of your devices. You can modify your sketch and program the devices. The initial phases of the development are typically done with your device connected to your PC via USB. The Arduino Create Agent is the application that you install locally in your PC that enables the cloud to communicate with the device in order to program it. Alternatively, once programmed, the devices can be updated without cables using the over-the-air feature. You have the ability to store all your sketches in the Arduino Cloud, and the web editor gives you the ability to manage and share them. The IoT Cloud platform is the way you have to interact with your devices once they have been programmed. You can connect your devices and define the variables that you want to synchronize with the cloud with bidirectional communication. Those variables can be managed from the dashboards using a rich set of widgets. Those widgets enable you to send actions to your devices or show the real-time or historical data of your devices. The IoT Cloud additionally has a simplified version of the online web editor, where the sketches of the things can be edited. This is very useful for beginners who could be somehow overwhelmed with all the web editor features and just want to focus on the sketch associated with their thing. You can access the IoT Cloud in many different ways. The most straightforward way is to use your web browser, but you can also access your dashboards from anywhere using your mobile phone and the Arduino IoT Remote app. Additionally, there are many other ways to interact with the IoT Cloud that can be useful depending on your use case. For instance, using the command line tool called the Cloud CLI can be very convenient for users that want to automate tasks using scripts. Similarly, the API can be used to automate tasks or perform integration with other platforms. Some clients in different programming languages can be used as a wrapper for the API instead of using the API directly. Finally, you can use the Node-RED nodes. And last but not least, we have the integrations with third-party platforms like Alexa, IFTTT, Make.com or Zapier. So basically the process to work with the Arduino Cloud is a three-step process. You can develop online with different options depending on the needs and skills. You can use the ready-to-use templates for an out-of-the-box experience, or you can use the automatically generated sketches that can be completed with your code, or you can use the web editor to have the full Arduino IDE experience, but online. To program the devices, this can be done with the traditional USB programming over the air or through the command line. And finally, you can monitor and control the devices with the IoT Cloud. Well, so now let's jump into the most interesting part of the presentation and let's see what's new on the Arduino Cloud. The first thing that I want to speak about is the new supported hardware. We have added support for a bunch of hardware boards. Some of them are Arduino hardware, like the Opta Portenta H7, Giga, or the recent plant watering kit. But we are not leaving behind the ESP32 users, and we have included support for the C2, S2, and S3 platforms. Additionally, now it is possible to do OTA, over-the-air updates, for ESP platforms too. This was a feature only available for Arduino boards in the past. One of the recently released features that we are more excited about is the phone as a device. The Arduino IoT Remote app, which is available for Android and iOS, was designed with the goal to control and monitor your devices using the Arduino Cloud dashboards and offer full control in your hands from anywhere in the world. But we went a big step further and enabled users to use the app as an IoT device, collecting information from the mobile phone sensors and sending the data to the Arduino Cloud. This feature automatically creates in the Arduino Cloud everything needed to monitor the sensors. That is the device, the thing, and the dashboard. Starting to play with real hardware can be tricky for non-experienced users. So this feature enables users to get familiar with the Arduino Cloud device management environment without having real hardware and using their own phone. Additionally, there is another cool feature. You can continuously monitor the sensors with the app in the background, and so you can use that data for real projects. If you think about it, a whole new world of possibilities opens up. You can now create applications that merge data from your phone with real-world actions. You can, for instance, use geofencing to define virtual geographic boundaries to trigger actions based on your location. With that information, you can automate tasks at home based on your location. For instance, turn the lights off when you leave, on and on when you return, lock doors, and adjust home climate control. Or you can keep track of loved ones and get instant notifications if they leave designated areas. But you can use other sensors like the accelerometer. For instance, you can use it to detect accidents when sharp decelerations are detected. Or you can just use all this information to create fun projects, like controlling remotely a robot with the mobile's accelerometer or creating a cool game. Only your imagination sets the boundaries of what you can do with this new feature. We are continuously listening to our users and trying to improve the user experience. For that purpose, we have included a couple of new widgets and have many more in the pipeline, as well as dashboard improvements. We recently announced an update of the percentage widget. These latest updates allows you to customize the widget with a variety of icons, making it easier to identify the purpose of the widget at a glance. You can choose from a range of predefined icons, including battery, temperature, storage, and more. Additionally, we have introduced the ability to set a threshold, and the widget's color will change when the value goes above or below a certain value, providing instant visual feedback. So, whether you're tracking your device's battery life or monitoring your storage capacity, this is the perfect widget for keeping an eye on important metrics. We also recently released the new advanced chart widget. This new widget is a significant upgrade from the previous chart widget, offering more customization options and functionality that will make it easier than ever to visualize and analyze the device's data. Its ability to display multiple variables in one chart allows for easy comparison of data points, making it particularly useful for tracking multiple data streams such as temperature and humidity in a greenhouse or energy usage in a building. Moreover, it is highly customizable, allowing users to adjust the colors and types of the charts, the labels on the axis, and the legend to make the data easier to read and interpret. One limitation of the standard chart widget is its inability to display data over custom time periods. The advanced chart widget offers the ability to select an arbitrary period of time, giving users access to the full history of their device data, according to the retention period of their plan. This is a crucial advantage for users who need to track long-term trends and patterns, enabling them to make informed decisions based on their device's complete data history. These two widgets were long-term demands from our users, and we are really excited to bring them to life. Next up, we have the Arduino Cloud CLI. This is a very powerful tool that enables users to access the major features of the Arduino IoT Cloud from a terminal. The Cloud CLI provides a new way to execute scripted operations on the Arduino Cloud, allowing for massive device provisioning and making it a long-time demanding feature for skilled users. With the new Cloud CLI, the Arduino IoT Cloud now has a full suite of tools available for every kind of user. You can perform most of the tasks that can be done using the web interface, including creating, deleting, and listing devices and things. Things can also be bound to devices, and dashboards can be managed in a very similar way. One of the key features of the Cloud CLI is the ability to download templates of the dashboards, devices, and things in different text formats, such as JSON or YAML. This allows you to modify them and create copies of the entities with some properties changed, making it easier to upload the new templates to the cloud. You also have the ability to deploy over-the-air firmware updates to one or multiple devices. In summary, among many other use cases, the Cloud CLI is also well suited for scenarios where mass scale and automated actions are needed. It can be easily integrated into scripts, making it possible to streamline the provisioning process and even hook it to automation scripts. The Arduino Cloud now offers a wide range of new templates that can help you build amazing projects with minimal effort. These templates include the Cloud Energy Meter, which lets you monitor your energy consumption using a Maker Wi-Fi 1010 board, a Maker 485 Shield, and a Modbus compatible energy meter. With this template, you can keep track of your energy usage, reduce your electricity bill, and limit your environmental impact. Another exciting template is the I Love You pillow. We all know that being without that special person in your life can be difficult, but what if you could send love and affection remotely over the internet by just hugging a pillow? Okay, we can't really send hugs, but what we can send is a sweet emoji through a messaging app, triggered by you giving your pillow a hug. When you hug the I Love You pillow, you will hear the sound of a heartbeat coming from the buzzer inside. And depending on the length of your hug, a different emoji will be sent to a chat box in the Arduino IoT Cloud remote app. For pet lovers, the Pavlov's cat template is a must-try. This project lets you train your cat to respond to a sound just like Pavlov's dogs. With this template, you can have fun with your cat while also exploring the capabilities of the Arduino Cloud. Or if you don't have any cats, you can create your own one using the Nerd template. Other templates include the Plant Communicator, which helps you to monitor your plants, and the Plant Watering Kit, which allows you to build a smart garden setup with the Nano RP 2040, a pump, and a moisture sensor. These projects are perfect for those who want to develop their own greenhouse and improve their gardening skills. In conclusion, the Arduino Cloud's new templates offer a wide range of possibilities for makers, developers, and enthusiasts. Whether you want to monitor your energy consumption, train your cat, or build a smart garden, there is a template for you. Okay. These projects are designed to be fun, educational, and environmental friendly, and they showcase the power and versatility of the Arduino platform. Okay, and those are some of the glittering features that we have recently included in the Arduino Cloud. But what's new to come? At Arduino, we are committed to providing Arduino Cloud compatibility for every new connected board that we announce. But we are also focused on enhancing our platform to support other platforms and technologies. So stay tuned for new updates related to new hardware. One of the key areas we are currently developing is event management and notifications. We are excited to share more details on this soon. In addition to this, we are also working on introducing new widgets and further enhancing our dashboard functionality. But that's not all. We are always eager to listen to our users and make their experience even better. That's why we are planning some major changes to both our web and IoT Cloud editors, as well as renewing the platform's navigation to make it more intuitive and user-friendly. So we have exciting times ahead, and we are really excited about sharing more news soon. And this is a wrap. I hope that you found this presentation interesting, that you enjoyed it, and that you learned something new. Thank you very much.
Hello, my name is Eliza Kasoy, and I'm honored to be speaking with you today at Arduino Day 2023. Firstly, because the number one question I get when I talk about my product is, what is an Arduino? So I'm really excited to not have to answer that question today. So who am I? I'm Eliza Kasoy. I'm finishing my PhD at UC Berkeley, where I work at the intersection of child development and artificial intelligence with Professor Alison Gopnik. I'm also the founder of Eliza Dolls. Eliza Dolls are 18-inch dolls, which are the same size as an American Girl doll, if you're familiar, that have Arduinos inside that teach young girls starting as early as 5 years old how to code and tinker with hardware. So in 2019, women made up only 27% of the STEM workforce. And as you can imagine, and perhaps some of the women in hardware who are watching this talk can empathize with, this is a huge problem for a myriad of reasons. During my career, I've spent time in various places where I found myself being one of very few women in the room. I started thinking about how to fix this during my PhD and had the realization that teaching these concepts really needs to start early in childhood. So I started doing STEM outreach and volunteering at public libraries. I was teaching kids about hardware and coding, using things such as the Makey Makey toy and other coding toys, which I was a huge fan of, until I realized that girls seemed less interested in what I was teaching, and it didn't seem to be their fault. When you Google STEM or coding toys, this is what comes up. Notice how blue and dominated a lot of these images and toys are. There's a lot of little boys playing, there's robots, there's race cars, there's soccer balls, and maybe this is one reason why girls seemed less interested. So this is when I had my epiphany moment. We need to have a coding toy made just for girls. As a former doll-obsessed child, see my photo here with one of my signature cardboard homemade doll houses, I knew it had to be a doll. And that's how Eliza Dolls was born. So what is an Eliza doll? The Eliza doll is an 18-inch doll that has an Arduino inside. Currently, I'm using the BBC microbit, and she works by having sensors plug into her ARM ports and unlocking more features. The doll is coded through the microbit app, which uses Scratch-style block coding, which is the standard for teaching children how to code. And then that code they create in the app gets sent over Bluetooth to the actual doll. And once they get really good at the block coding, they can even code in JavaScript. So what kind of projects can you do with the doll? We have a couple of plug-in sensors that work with the doll to expand the project capabilities, in addition to the built-in sensors that already exist on the microbit. One of these is the distance sensor, which allows you to make projects such as a security alarm to keep out your pesky brother. We have a plant moisture sensor, which allows the child to monitor the moisture and water levels in various plants around the house and see when they need to be watered. We have a pulse sensor, which allows you to build even a primitive activity monitor or a truth detector. And now we're going to take a look at a small demo. And this is our resident cute child named Maria, who's going to demo two projects, one with the pulse sensor and one with the distance sensor.
We're using a pulse sensor, which measures your heartbeat. You can use the pulse sensor to make exercise trackers and so much more. To use it here today, Maria's going to put her finger on the pulse sensor and I'm going to ask her a question, and then it's going to show if she's telling the truth or not. So, Maria, who do you love more, your mom or your dad?
My mom.
Let's hope your dad doesn't see this. Here we have a demo of a theremin. Basically, it's a magic piano you play in the air with your hands. We're using an ultrasonic distance sensor, and the lights are reacting accordingly. You can also use this sensor to build security alarms, motion detectors, and much more.
Cool. Thank you, Maria. And obviously there's a ton more we could show you, but I have a limited amount of time. So lastly, I just wanted to show you some research I conducted during my PhD about girls' coding preferences. The choice of a doll was intentional, and it's deeper than the notion of just make it pink and girls will like it. So what I found in one of my studies was when you asked girls and boys ages 5 to 12 what interface they would prefer to code an Arduino in, obviously we explained to them what an Arduino was, almost 76% of girls prefer to code an Arduino inside a doll format, and 95% of boys prefer to code it in a race car. I also found that just one 10-minute positive interaction with coding and hardware using the doll increased young girls' interest in these topics, as reported by their parents in a follow-up study. So I'm planning to launch on Kickstarter this summer with our Liza doll version 1.0. If you're interested, go to our website and join our mailing list to be alerted when we launch. We also have a funny video coming soon. So please follow me on Instagram or Twitter to stay updated about our process. We have a TikTok coming soon. Thank you for your attention, and be sure to join our mailing list or follow us on social media to really get all the updates about our launch. And if you scan this QR code, it'll take you to our website. Thank you so much, and thank you for having me here today.
It might be small, but the Arduino Nano RP2040 Connect is mighty because it's connected, because it can talk to other devices, computers, projects, and even your smartphone through Arduino Cloud. Just imagine the kind of ambitious, creative things you can build with wirelessly connected devices that fit in the palm of your hand. Because the built-in microphone means it can interact with you and the world around it. You can't even imagine where the Nano RP2040 Connect will take you, but it knows where it's going. The miniature Nano RP2040 Connect thinks big.
Hello and welcome back, everybody. And don't forget, you can actually get 10% off the Nano RP2040 Connect right now on the Arduino store if you're interested. So please take a look there. Right, moving on. We're going to have next Becky Stern. Many of you will know of her as the content creator and STEM influencer. And Becky's going to show you all some of her favorite projects that she's created herself, but also that her students have made. And what's really interesting about this presentation is it shows the full Arduino ecosystem. So it uses a mixture of boards, but also a whole host of Arduino libraries. So really just a good one to take a look at to see what you can do with Arduino, ESP32, 8266, and so forth. And it's worthwhile noting you can use the Arduino Cloud to control your ESP projects as well. And then following on from Becky, we will actually have Ronnie with his Rainmaker machine, which I'm actually based in the north of England. I know you can't see behind me, but it is pouring with rain now, which makes me think he's left it running behind the back of our house. And so it's obviously been a successful machine. And then following on from that, we have Marwa, who's showing us some automation projects she's created around her home in Algeria, and that uses the Sandy Android application. So over now to Becky to show you her favorite projects. Enjoy.
Hi, everybody. I'm Becky Stern. I'm a maker and a YouTuber, and I live in New York City. Thanks so much to the Arduino team for having me today. I want to share with you some projects of my own that have used Arduino. I've been using Arduino since 2005 when it came out, as well as some of my student work where I teach at School of Visual Arts in the Products of Design graduate program. So let's just get started, shall we? My most recent Arduino project is a toy recreation. It's a Wheelo in the shape of a letter T. I participated in YouTube Maker Secret Santa, and I got this old Tony. So I made a wire bend piece using this CNC wire bender, and then I added LEDs to the wheel itself. I used a Xiao RP2040 microcontroller board and a light poly charger and some teeny tiny NeoPixel strip, as well as a switch. And the whole thing became therefore USB rechargeable, and I could put on whatever cool LED patterns I want. I also 3D printed the handle. So you can find the circuit diagram and all of that stuff on my website. Next up, I want to show you this webcam privacy cover I made. I can actually demonstrate this for you live because I use it on my computer all the time. So it's got a button, and then when I press it, it opens and closes to cover my webcam. It also has a real-time clock and a potentiometer, so I can spin the potentiometer to increase or decrease the amount of time that the webcam will stay open. And then when the timer is expired, the eyelid will close and cover my webcam. That's kind of why it's better than a piece of tape. And so you can find out how to build this one. Also on my website uses our Arduino code and Trinket or RP2040 board and a real-time clock. And it's a pretty easy project to grasp if you're a beginner, and the 3D printed parts are pretty fun. You can elaborate on your own eyelid design, so you can also download my files. And my friend Ajay also helped me work on some of the creative for this project. Super useful. I use it every single day. Next up is this Larson Scanner scooter. We have this 80s scooter, and it just was ripe for the LED-ification. This is also a very simple project using Phil B's simple Larson Scanner code. Yeah, inspired by all the 80s things that had this kind of LED situation going on. It's just a Trinket or other small microcontroller wired up to some NeoPixel strip and then glued into the grill of this 80s Honda scooter using some waterproof glue. And then we wired the switch to under the seat so that it could be turned on and off independently of the bike. So that like when the bike is off, you can still show off the Larson scanner. What's funny about this is you go to a motorcycle show or event where you park it and then you want to show off the Larson scanner so much that it kills the bike battery and you can't start the bike again. That's happened and that's really funny. And then you have to get a jump start. Next up, it's my Slack status updater using an ESP8266. So this uses the Slack API and updates your status with one of a few pre-saved Slack statuses. My pal Brian Locke worked on the Arduino API library to hook into Slack. You do have to have some workplace privileges to make it happen, but so I used a rotary switch, which is not to be confused for a rotary encoder, and I 3D printed a little very basic case that I modeled in Tinkercad. I crammed all of that stuff in there with you can use like a Node MCU board or your favorite ESP8266 using Brian's Slack API library. Here's some prototyping. Next up is my cat food bowl. This is something I built for my sadly passed cat Chaz, who was diabetic. And when he was diagnosed with diabetes, we had to start feeding him at a particular time so that he could have his insulin given to him on a full stomach. And that meant cutting off his late night snacking. Now, he loves to late night snack on his kibble, but I had to stop him from doing that. And he's not a particularly strong or young cat at the time. So there are commercial gadgets that do this if your cat like breaks into stuff, but Chaz didn't need that much reinforcement to keep him out of the food bowl at night. It's just the ESP8266 and it uses the network time Arduino library to check whether it's like okay time for Chaz to be eating a meal. So it turns off, shuts it at night and then it opens it in the morning. So you can grab my files. It's pretty simple code for detecting what time it is and then making an action based on that time on a network connected board. Next up is another scooter project. I put LED underlighting on my Vespa scooter and I made it Bluetooth controlled. So this was a super fun project. There's like a lot of payoff for the effort here because the circuit is just two LED strips. In this case, I think they're dot stars, but they could also be neopixels if you had those. This Bluetooth module and a rechargeable battery, and it's in a waterproof case. So while this isn't wired into the bike's power, it's a pretty easy, non-invasive thing to attach on, and I can also like remove it when I want to take it off or charge it. And it magnets on, so the bottom of my bike is metal. But this would easily also be permanently installed if you wanted it to be. So just like everything else I published, I've got a circuit diagram, and you can download my code and look at my materials list. This was a fun project. I admit I don't use it terribly too often. And of course, it's not exactly street legal in most places, but it's good for a fun time on private property. And lastly, I want to share a project I did for some television. This is a jacket Buzz Aldrin wore on the Late Night with Stephen Colbert. And I didn't design this. I took the costume designer's sketch and I added LEDs to this jacket. I got to watch the show from backstage and meet everybody. It was a pretty exciting time. But I also published a little tutorial and a circuit diagram so you can follow along too. It's just some NeoPixel strip. And, you know, like I did bring along a fun animation to try, but then, you know, like we do a lighting test on stage, and of course, PWM and like camera shutter speeds don't usually love each other. And the animation just like looks like flashing on the camera. So of course we went with the solid blue. So it's just to say that like less is more. And so those are my Arduino projects. So I'm gonna move on to some student projects. Here's one that's the spicy roller meal decision machine for when you are indecisive about what to have. You can roll the slot machine and it will suggest some meals for you to try. This one uses an Arduino and a soundboard and some cardboard construction printouts and some LEDs at the top. I think that's a really sweet idea. Here's another student project. This is a punching mat for taking a break from your work when you just need to get up and wiggle around and maybe blow off some steam. You can come and punch this thing. It's got sensors in the mat, so you can count up how many times you've punched it, and it'll, with the LEDs around the side, count down a reasonable time frame for you to be letting it all out and trying to rack up maximum punches. Super fun. Here is a air quality visualizer made with plastic sheeting that's been laser cut, LED strip in between them, and it's using the ESP8266 to ping an air quality API and then translate that information into colors so that you can know how bad the air is before you go outside. And I think it looks super charming on the desk as well. This project has a proximity sensor and a piezo buzzer, and it's for keeping your cat off the bed. The student had a problem with the cat going to the bathroom on the bed while she wasn't home, and so she built this proximity sensing Arduino circuit that beeps at the cat to scare it away when it's on the bed. So you kind of arm the device when you're not there, and it's this funny cardboard cat cut out with LEDs in the paw beans. Love it. This one is a lamp that mimics a water surface, so like a ripple effect, but in lighting when you touch it. Most of these students are first-time Arduino project builders. It's a 15-week class, and this is their final project. What's cool about this one is she prototyped her animation in some kind of screen simulation software that she liked to use and knew a little bit better than Arduino, and then we were able to work out how to translate that into the LED code. This one is a funny one. This is a toothbrush that tattles on you if you don't brush your teeth twice a day for 2 full minutes. It will uses the Twitter API, and it'll post to the internet with some kind of silly message. Uses IFTTT and tries to embarrass you if you don't meet your teeth brushing goals. It's pretty funny. It's just a retrofit and a 3D printed enclosure around an existing toothbrush. I thought that's a great way to prototype. And lastly, I want to share this LED piggy bank half marathon training progress lamp. It lights up every time you log your training data for that period and until it shows that you're all full up. This display would also work well for several other of the IFTTT APIs, like showing that you've saved money and made a transfer into your savings account. But it's neat that you can visualize Strava data and Google Docs data in this fun way. The lamp is made out of laser cut acrylic and has these segments here so that when the LEDs shine through, they light up the particular segments. I think it's super nice. You can find all of my student projects on my Instructable Collections list. And I've been teaching this class for over a decade. So there are a lot. It's called Making Studio. And I'll just put the link too, but you can check out all of my students' projects in this collection from every single year. And then finally, I'd like to plug my Arduino intro video series that's going on right now on DigiKey. So there's 6 episodes of my Intro to Electronics series, and half of them are about Arduino and more to come. So check that out if you're new or you just want a refresher. I've got tons of tips and tricks going on in here, and I would love it if you checked it out. I've got one about digital and analog inputs, one about Arduino libraries, and much more to come. So thanks so much for checking out my projects and my student projects. You can find me at beckystern.com, and you can find out what I'm working on next by subscribing to my YouTube channel or find me on your favorite social media network.
Hi everyone, my name is Ronnie Bandini. I make strange machines mentioned in books and literature. From time to time I also make paid prototypes combining electronics, coding, 3D modeling, and also machine learning. I live in Buenos Aires, Argentina. Maybe you know Argentina because of the tango, the soccer, or the meat. But we have also an interesting story about a rain-making machine. I have several projects published. Some of them are Rasuelomatic, a device to generate reading paths for a hopscotch novel by Julio Cortázar, The Machine to Think of Gladys, based on an intriguing short story by Mario Lebrero, a tiny Kindle for reading haikus, and the Literature Dispenser, a machine to get short stories printed on tickets, among other machines. The project I am showcasing this time is something called the rain-making machine. First of all, I would like to explain one little thing. The name of the project could be misleading. While there is a discipline named Plaviculture that focuses on producing rain, this is a homage machine to a real story that happened in Argentina almost 90 years ago. In those years, an inventor named Juan Baigorri Velar was using a custom-made machine to detect minerals. When he observed inexplicable rains, he modified and tuned the device to detect minerals into a rain-making machine. According to the newspapers, he traveled to dry zones in Argentina like Santiago del Estero and San Juan. He promised rain for certain dates, and rain occurred. He did this several times, but he never let anyone inspect his machine. Eventually, his popularity faded away, and the rain-making machine was never found. A book about this Juan Baigorri Velar story was recently published, including some statements with technical details. So the aim of this project was to remake his machine, or at least a version of his machine, using those statements, which I tell you in advance with today's knowledge, they are incomplete, cryptic, and sometimes even preposterous. For this project, I have used an Arduino Nano 33 BLA Sense, a board I really like since it is tiny, it has onboard sensors, and is powerful enough even for machine learning projects. I am also using a 2-channel relay, a 5-volt 35 kilos electromagnet, a 12-volt 60 watts Peltier cell, 1 selector, 1 toggle switch, a vintage 5-volt light bulb, 2 analog view mirrors, an antenna from a CRT TV, a vintage enclosure, and some 3D printed parts. So let's go back to the statements now. There, Baigorri Velar talk about atmospheric waves. So I have used the Arduino onboard barometer to read atmospheric pressure. Baigorri Velar talk about certain chemical and radioactive materials being manipulated. So I use a small stainless steel cup to hold components, and that is placed over a Peltier cell. I pour a mix of phosphorus and charcoal here, white phosphorus and charcoal. In Civil War times, after gunpowder battles, rain was very likely to happen. A possible gunpowder formula is 75% nitrate, 15% charcoal, 10% sulfur. Due to Argentine asado grill, I had phosphorus and charcoal available in my house, and in any case, I did not expect to produce rain. Baigorri Velar formula was also a secret, so that is my mix of preference. By the way, I did not use radioactive materials, first of all, because I don't have them, and also because I watched the Chernobyl documentary and I kind of appreciate my own life. Baigorri Velar also talked about electromagnetism, so I have an electromagnet connected to a relay as well inside the machine. The period of heat and electromagnetism is regulated by the Arduino according to the progression of the atmospheric pressure. I have coded a simple formula to store 1 atmospheric pressure reading per minute and detect drops that are usually related to rain coming. Since the coding and the general design were not so challenging this time, I've decided to invest more time in the enclosure and general look of the rain-making machine. I found an old timer made in Argentina, this one, that even when it did not resemble the original wooden box, it was perfect, just perfect to contain all the components and controls. And it also had a similar opening mechanism as the original machine. I've added a switch from an old Italian Pesa heater, an analog 2-channel view mirror, a vintage light bulb here. Regarding the power supply, I've used a dual 12-volt, 5-volt power supply from an old iOmega disk. I had that power supply for years in my drawers, knowing that maybe his time would come. The 12 volts are used only for the Peltier cell. A little note about the Peltier cell. In some articles about the machine, it wrongly says that it generates cold to the stainless steel cup. In my wiring, the Peltier cell generates, in fact, heat. It took a week or so to make the machine without considering the time to get the vintage parts. Most of this time was used to design the 3D parts to fit the components in the enclosure. All this part and to connect this and the antenna. And this is how you operate the rain-making machine. The toggle switch turns on the device. Now the barometer inside the Arduino is recording 1 reading per minute of the barometric atmospheric pressure, into the array. After 1 hour or so, the machine is able to make a rudimentary rain prediction that is displayed in the right view mirror. Left view mirror has current atmospheric pressure. If you turn the selector to the right, that prediction will control the timing of the Peltier heating and the timing of the electromagnet. Allegedly, with the right mix of chemical and radioactive materials and leaving the machine running for 50 hours or so, rain could come. Why invest time and effort in a rain-making machine that almost for sure will not make it rain? I firmly believe that the mere existence of any machine articulates with the world and people in ways we as inventors and makers could never imagine. Recording this event, the whole internet is for sure linked to the Mechanical Turk, a machine that allegedly played chess, but it turned out it has a small chess player inside using mirrors. The mechanical Turk inspired Charles Babbage to make the first analytic engine, and following this path, a real chess player machine was later a reality. So who knows what kind of influence this machine or any machine and story could have in other people. So this is all for today. I hope you like the project. If you want to get in touch about this or any other machine, again, I am Ronnie Bandini, and you can find me on all social platforms by searching Ronnie Bandini. Thank you very much.
Hello everyone, I'm Marwa Bouafia from Algeria. I'm Information System Engineer. I'm really so happy that I can join you today on the Arduino Day 2023. Happy birthday, Arduino! My journey with Arduino started last year as a part of my end of study project where I work master thesis under the supervision of my supervisor, Mr. Yahya Atik. So we worked on a smart house monitoring system using a smartphone. I get my master degree from Salhi Ahmed Naama University Center. Smart house is one of the applications of the Internet of Things. It's where we can manage and control devices in the house remotely by digital command or vocal command. It's aimed to make security in-house, also energy efficiency and safety, and also comfort in the house. Architecture that I use to experiment the smart house is that I made Android application, call it Sandy, based on communication protocol of a Bluetooth and Arduino Uno that we can manage the device of house. That's it normally, and this is what I will show. Here is Sandy Smart House System. As you see here, it's the logo of application. The protocol used is Bluetooth, and here is the QR code of the application. This is the Android application. We have two choices, to sign up and sign in. To sign up if you don't have account, so you need to enter your username, your email, your password to submit. I have already account, so I will sign in directly by scanning the QR code. Now I can divide the part of the house into three parts. We have the previewing, the control, and manage the appliance. For the previewing, we have weather and camera. For control, we can control devices. It can be door, external or internal, lights also external and internal, and other smart device. We have also two control factors. The factors can be temperature or water. Also the events. The event we have gas and fire detection. For the next, we will see the fire detection. For managing the appliance, we have digital command and we have vocal command. As I focus on the parts of sound and vocal, let's try the vocal command. First thing, we need to connect the application to the circuit. The circuit is composed by Arduino Uno. Here is the Bluetooth HC05. We have a LED and on the breadboard and resistance. First thing, I need to connect the device to the Bluetooth. So connect HC05. Okay, it's connected. Now let's try to turn on and off the LED from the application. First thing that we need to upload the Arduino code to the breadboard. Here is the code. Upload it to the card. Uploading done. It's okay, we have already connected. Now we need to speak. Turn on. Here I switch it on the lamp. We can try to turn it off. We need to speak also. Turn off. Here is the circuit, Arduino Uno. We have breadboard with a buzzer and fire detector. Let's upload the code. Uploading done. Now let's try it with fire. With the clock sensor, now we need to upload the code. So, okay, it's verified. Upload it. Uploading done. As you see here, the clap sensor, and this is the LED. When I clap, let's switch it on. Smart house is a varied system that involve more in the future. As I focus on the vocal command, I think that one of my next projects will be Arduino talking bot that assisted in the smart house itself to make more connectivity, to make more communication and more helpful in the smart house. That's it. Nice talking to you. If you have any question, don't hesitate to checking me directly, Marwa Bouafia on LinkedIn. If you have any question, I'll be more than happy to respond, and goodbye.
Hi, welcome back, and thanks to Ronnie and Marwa for sharing their projects. And just to show that we're covering all of the elements today, we've got Jean and her Whirlwind radio coming up in a few minutes, and that will be followed by Reem, a student from Egypt, who's going to explain how to choose the ideal Arduino board. And don't forget, you can get 10% off those on the store. Sorry for that. That's just to show it's live TV. That is our dog trying to join the celebration. But first, before we go into those projects, we're going to take a look at the Arduino Project Hub. So at the end of the year, we brought it back in-house to be able to integrate it with the Arduino Cloud further. And Max, one of our engineering team, is going to show you all of the features. But firstly, I just want to say a big thank you to Hackster for originally collaborating with us to grow a space that hosts thousands of projects created by yourselves. So a big thank you to all who've contributed to Project Hub over the years. So without further ado, over to Max.
Hello everyone, thanks for being here. I hope you are enjoying our Arduino Day live streaming. I'm Max from the engineering team, and I'm here today to talk to you about an amazing platform that has changed the world of do-it-yourself electronics, Arduino Project Hub. If you're not familiar with Arduino Project Hub, let me give you a quick overview. Arduino Project Hub is an online platform that allows users to share their Arduino-based projects, collaborate with other makers, and get inspired by the community. It's an essential stop for all Arduino users, offering a wide range of projects, tutorials, and ideas to help everyone get started with Arduino. And it has been completely redesigned in 2022 with additional focus on usability and accessibility. So let's have a look at the interface. Everything starts from the brand new homepage, where you can see the top trending projects updated on a daily basis according to the most visited projects of the previous days. Projects are then organized into categories, such as home automation, robotics, or Internet of Things, where users can sort or filter in order to easily find what they are looking for. Let's now see how a project looks like. Each project comes with a list of required components, detailed step-by-step instructions, schematic diagrams, and other essential resources, making it easy to replicate the project at home. The code section is also perfectly integrated with Arduino Cloud Editor, allowing easy code sharing with community members, as well as quickly importing a whole project, editing and testing it directly from your browser. But Arduino Project Hub is more than just a repository of projects. It's a community of makers who are passionate about electronics and want to share their knowledge with others. By sharing their projects, users can get feedback through the comment section and learn from other makers, but also get respect for their work and build a portfolio of projects that can be shown to potential employers or customers. While browsing the huge projects archive, users can also take advantage of common features such as bookmark or social sharing, or simply follow their favorite makers. In this way, Arduino Project Hub is not just a platform for do-it-yourself electronics, but it's a platform for creativity, innovation, and social interaction. In addition, Arduino Project Hub is a great resource for educators who want to teach electronics to their students. The platform has a wide range of projects that are suitable for different skill levels and are accompanied by detailed instructions, making it easy for teachers to find the ones that are appropriate for their students and for them to follow along and learn the basics of electronics. In this way, makers publishing their projects on the platform are also contributing to STEM education. Now, let's talk about the software architecture. Arduino Project Hub has been redesigned not only from the user experience standpoint, but also from the architecture to be flexible, reliable, and scalable. The platform is now built using modern web technologies such as React and Next.js, allowing for the creation of highly performant and scalable web applications. The REST APIs, that are the backbone of the platform, are developed in Python and deployed into containers using Elastic Kubernetes Service on AWS Cloud. This ensures that the application can handle a large number of requests and meet high availability standards. A strong focus was also put on security. Authentication is supported by the Auth0 service by Okta, allowing for a seamless single sign-on functionality across the entire Arduino ecosystem. All sensitive data is encrypted using industry standard algorithms, and the platform is safely stored on AWS infrastructure, right next to our amazing Arduino Cloud. Finally, let's have a look at the future. Arduino Project Hub has been designed to be an evolving platform, so you can expect to see even more exciting development in this space this year. A first enhancement will be a better integration with Arduino Cloud, allowing for easier interactions between projects, sketches, and IoT templates. This will make it even easier for creators to work with Arduino devices and to access their work from anywhere, collaborate with others, and share their projects with a wider audience. Another key focus of development will be oriented to the amazing Arduino community. Arduino Project Hub will have more features that will allow makers to connect and collaborate with others, sharing their ideas and getting feedback from other like-minded individuals. And don't forget to take part to our Arduino Project of the Month competition. There are a lot of gifts just waiting for you. Last but not least, as it is common to all Arduino platforms, even more effort will be put into the performance side. The platform will continue to be optimized to provide faster load times, smoother user experience, and an always reliable service. This will ensure that makers can boost their productivity, focusing on their projects. So, the future of Arduino Project Hub is full of brand new functionalities and integrations, making it even more important resource for makers and creators. So, let's get out there, start creating, and share our ideas with the world. Thanks for watching and have a nice Arduino day.
Hello, I'm Jeanne Arignan-Doki. I'm a French art director and creative technologist based in London. I work in a creative studio across different kinds of projects, from campaign, branding, experiential, or artist commissioning. When I'm not at work, I like to experiment with hardware and especially Arduino. I will say that my own practice lies at the intersection of digital and analog design with a particular focus on tactile objects, so anything people are going to be able to touch or interact with in a physical space. And I attach a lot of importance on creating pieces where technology does not alienate the audience. I will say that I really enjoy creating humorous and surreal encounters between daily life, daily moment, and incongruous materials or objects to draw attention to meaningful topic. I'm here today to introduce you to my project named Whirlwind Radio, which you can see part of it right next to me. It's a piece I've developed during the program I attended at the School of Machine Making and Make-Believe in Berlin in summer 2022. Whirlwind Radio is an interactive sound installation harnessing nature's strongest force, the wind. It takes the appearance of a windsock, as you can see on this image, and plays a radio station from a different part of the world depending on the speed and direction of the wind. As you can see on this map, there is different locations depending on the wind speed and again direction. So if the windsock is routed in Berlin and a small breeze blows from the southeast, as you can see here, it will be playing live radio from Romania, Iran, India, Malaysia, or even Australia if the wind is very strong. You might wonder what happens if there is no wind. Well, it will still work. It will just simply play the local radio. So in this case, Berlin Live Radio. I'm going to show you now a video that's going to give you a good idea of how the installation looks, but also, most importantly, how it sounds like. On those photos, you can see some close-up of the installations. So on the left, the windsocks attached, and on the right, the two different sensors used in this installation. So in this 3D printed part, you have an anemometer that will collect the wind speed, and a rotation angle sensor that will look into where the windsocks point at and give information on the wind direction. Here you have the box that contains the speakers, the screen, but also all the hardwares necessary for the installations. So we have an Arduino, a Raspberry Pi, and a power bank. Here, little attach from the windsocks to the pole. This is actually a very important piece. I hand sew myself the windsock with a nylon fabric. In this project, I wanted to highlight the importance of cultural flow by erasing geographical borders through sound and really communicate how diverse cultural exchange makes the world a more beautiful place. And I really like this idea how the wind embodies the immigration of life. It can carry seeds, sands, or even help birds to cross continents. And now we know that actually the wind plays a beautiful role in world diversity. And similar to that, radios are also a living thing, filled with curated music based on what moved the people of a nation. It's a bit like a snapshot of the cultural landscape of a country. And like the wind, electronic airwaves know no borders. Before I dive into more detail on how it works, the installation, I would like to thank the amazing Rachel Uwa, founder of the School of Machine Making and Make-Believe, Quinn Tincher, Sarah Rescher, Alexei Grichenko for their support, help and encouragement all along me working on this project. So let's look how the installation works. So you understood it. The winds come in, and the wind speed and the wind direction are captured by two different sensors, the anemometer and the rotationary sensor. Those information or data are being read by an Arduino that kind of pair the different values. And those pairing are being sent then to a Raspberry Pi that will then trigger the online radio URL depending on the different value received through a music player diamond. It will display on an LCD screen the wind direction, the location, and the radio name, and play the music through the speakers for the audience to dance and enjoy. This is the first prototype of the installations. So after around 2 weeks of work, and you can see it's a cardboard tube. The wires are actually not fitting into the box. Actually, big learning here. Always take the dimension not just of the hardwares but also of the cables and wires, that it take a lot of space. This is the original colors of the windsock, and as you can see, I use a lamp shade structure to hold the windsocks to the main pole. It was actually funny for after those 2 weeks when we presented the first prototype, there was no wind. So I had to run around the park to show how the different radio would be playing depending of the wind speed and wind direction. Yes, you can see here all the different pieces of hardware that was supposed to fit in the box and that didn't fit for this first presentation. After those 2 weeks of work and this first presentation of the installation, I keep working on these installations, just refining the design, the different 3D printed parts, as you can see here, you know, from the first sketches to the first version of the design that were very big and square to something slightly more refined toward the end, and obviously spray painting it in white to fit with the pole. Similar to the box, basically making the box a bit bigger to fit everything nicely together inside. And the windsocks itself, just refining the colors and the story of the colors. The final outcome with the yellow, the blue and the white, basically the sun, the blue of the sky and the white of the cloud. What's next for the installation? Well, I'm currently looking into making it powered by the wind. I think that would be amazing for the story of the installation. And if you have any experience with that, please don't hesitate to let me know and share your experience with me. Secondly, the installation has been invited in a couple of festivals this year in the US and in France. Please, if you like to host a piece or know any event or institution that would be interested in presenting Whirlwind Radio, please send me an email at this address. Thanks to Arduino for the invitation, and thank you for watching.
Hello everyone, how are you? I hope you are all good. Today, I want to help you how to choose the most suitable Arduino board for your project. This is me. My name is Reem Ahmed. I'm from Egypt. I am a senior student who studies computer science and mathematics. I love programming and I'm interested in robotics and machine learning. Last year, I was a core team at Google Developer Student Club at Alexandria Higher Institute of Engineering and Technology. Currently, I am an event coordinator at Microsoft Student Partner at Helwan University. Arduino made a lot of different boards that can help everyone, including students, hobbyists, and programmers, to build electronics projects. You can use Arduino boards to build various and countless projects. These amazing boards can be used in robotics, some of them can be used in IoT, and some of them can even support machine learning using MicroPython. For sure, I can't mention all of these boards, but I will talk about some of them. The first board we will talk about is Arduino Uno. Arduino Uno is the most well-known board. In addition, it's the most suitable board for beginners. So, if you're a beginner, this will be your best choice. You can use this board to build many different electronics projects, such as robots. For example, you can use it to build robot cars or robot arms, for example. The next board is Arduino Mega. As you can see, it's larger than Arduino Uno and it contains more pins. This will help us to connect the board with more sensors and actuators. And this will help us to build larger projects and robots. This is Arduino Nano. This board is smaller than Arduino Uno and Arduino Mega. This board has a really wonderful feature. This board is a breadboard friendly, which means it can be inserted into the breadboard. This will help us to create neater projects. This board is also suitable for beginners. There are a lot of versions of Arduino Nano. For example, we have Arduino Nano 33 Blessings. This board will be a great choice if you want to build a project that supports machine learning. You can program this board using MicroPython. In addition, it has a really amazing feature. It has a set of embedded sensors, such as temperature, humidity, pressure, motion, microphone, and much more. This will take your project to the next level. If you want to combine between clothes and electronics, then look no further, because Arduino LilyPad is here to help you create a lot of cool wearable projects. For example, you can use this board with gloves, t-shirts, earrings, or even shoes. And the last board we will talk about is Arduino MKR Wi-Fi 1010. This board is an improved version of Arduino MKR Wi-Fi 1000. If you want to build IoT projects, then this will be a great choice because it supports Wi-Fi connectivity. In addition, it supports Bluetooth connectivity. As we saw before, we compared between different boards according to the main use of the board. You can also choose the most suitable board according to the number of pins. Larger projects need more pins. Memory is also an important criteria to choose your board. Larger projects need more programming and need more coding, so they need more memory. You can also think if you want to build a project that needs Wi-Fi or Bluetooth connectivity. If you want to build time-critical projects, then you need a fast board. But if you want to save power, then you will need a slower board. But how can we find this information? We can find them at the specifications table. This table has a lot of useful information, such as input voltage, microcontroller name, clock speed, memory, number of pins, length and width of the board, and much more. You can find all Arduino boards in this website. You can also look at any board you want to get more information about it, and also read the specifications table. So this is the website. You will find here all the boards made by Arduino. For example, you want to know more about Arduino Nano 33 IoT. So you will click here. You will find a picture of the board. You will also find an overview about the board. You will also see the specifications table. And if you want to buy this board, you can buy it from here, from the store, and add this board to the cart. Thank you for being here. It was nice to meet you, and I'm waiting for your questions.
So the video we just saw is actually from our new Opta, which brings us to actually our next presentation, led directly by our Arduino Pro team, which are Marta, Francesca, and Stefano. And they're going to explore the latest solutions, use case studies, and trends for developers. After that, we'll have the pleasure to check out how Jason has built a high-level robot using Arduino technology or combined with Raspberry Pi and wheelchair base. After that, we'll have Jody, who will introduce their project of a personal robot assistant, a personal robot who can help us in the daily life tasks and using artificial intelligence and Arduino Uno, making it use as a picture box software. So over to our speakers.
Hello everyone and welcome to Arduino Day 2023. We are in Torino and I have the pleasure to introduce you one of my favorite colleagues, the Pro product managers, Marta and Francesca.
Hello. Hello everyone.
So what I hear it has been how many products we launched together. And talking about the many novelties we have in the Pro line for the professional targeted products, let's start with one of the most interesting families because it kind of stays in between from professional but also makers, which is the Nikla family. And it's one of your products, so go ahead.
Ah, it is. So what comes to your mind when you see one of these?
You go first.
It is very, very small.
Yeah, and also it's packed with components that there's everything here.
Yeah, look at them. So we have 3 Niklas at the moment. The Nikla Vision, that is the one that I have in my hands, with vision capabilities, really smart vision capabilities. We have a camera, we can see all the world around with this board. And then, what else do we have? Here we have the Nikla Voice. Sorry, I needed to read because it's so small that I couldn't read it. Nikla Voice to hear the world around, so to hear people, to hear sounds, whatever you like. And last but not least, the Nikla Sense Me. And the Nikla Sense Me has been developed together with Bosch to sense the world. So we can sense temperature, we can sense pressure, we can sense whatever we need. So what's in common between all of them? They are small, first of all. They can be battery powered, so you can actually place them wherever you like, and forget about them because they have a really long life. They are low power. And also they are connected, as most of our products. They are connected with Wi-Fi, Bluetooth, with the cloud. So everything can be at your hands anytime you like.
And they are edge devices, right? So they are capable of doing things right where the thing happens.
Definitely. You can run also some machine learning models directly on them. You'll have them really able to detect any kind of events and identify them.
So they can be trained to be basically independent and react.
Exactly.
And they interact with all of the product we do, right?
Yes.
In the Pro business line and Arduino in general.
Yeah,
cool.
The Arduino ecosystem is all connected. We have the same libraries for all the boards. So if you know how to use one board, you will for sure be able to use another one.
Right. And you can also leverage the castellated pins I see they all have, right?
Yes.
Why is that?
Yeah, they are there because you can, for instance, mount some headers, or you can even do automatic assembly lines with them, so you can assemble them automatically without any of being there.
And I see a lot of things in here. So let's say I want to buy several thousands of those, but I don't need everything in there.
Yeah, you can customize them depending on your need, of course.
Cool.
We are there to help any kind of request from customers.
Good to know. So this brings us to the next big novelty we had in the last year, which is a groundbreaking innovation for a traditional industry, let's say, right? A very ancient industry. Tell us something about it.
I saw your face. You had in mind something like traditional means boring.
That's your word.
That is not boring, absolutely. This is a very, very interesting product because it is something that brings a lot of news in this market and something that can really open a very wide set of opportunities for both Arduino programmers, but also for the programmers that are really used to the EEC 6, 11, 13-3 programming languages. This product, first of all, is of course a product with an Arduino heart that is based on a very powerful brain, because it is leveraging an STM32 microcontroller. So it is based, let's say, on our H7 platform, which is a very consolidated platform capable of doing, let's say, a lot of processing in terms of data. But on top of that, we have decided to create this micro PLC, which is a UL certified product, which means it is fully capable to work really in the industry, complying with all the industrial standards, but also leveraging everything to a higher level of connectivity, and giving the possibility also to interact with cloud services thanks to its connectivity features. This means that we can offer 3 variants of it. Natively, even the basic one has the Ethernet on board, which also allows the possibility to go cloud. We have also an intermediate variant, which offers the possibility to run Modbus through the Modbus RTU, let's say, terminal rack. And we have a third one, which also implements Wi-Fi and Bluetooth Low Energy radio.
Wow. You can do everything with that. Tell us a little more about the traditional IEC 63 languages. So when you say we can use Arduino, but also Ladder and other languages like that,
yes.
What do you mean?
I mean that natively, this product comes out to the market, let's say, pre-licensed for our users, so they can decide if to use all the 5 standard programming languages with Opta, or the Arduino IDE, or let's say also both together, because we can also enable, thanks to the shared variables, the possibility to merge an Arduino sketch together with the IC programming languages.
Nice. Very interesting. So we will have a PLC IDE that is already available in that once you purchase it, right? A dedicated PLC IDE that works together with the Arduino ecosystem. Is that correct?
We have it already, let's say, for our Portenta machine control product. So the experience will be very, very similar, a bit customized, of course, for the IOs that we expose for Opta. But this is the same type of experience that was, let's say, already well evaluated by some of our customers of the Portenta machine control. The type of experience is the very same, and we will give it natively also on Opta.
Nice. So, and we also chose a special partner to develop this product. Tell us something about it.
Yes, exactly. You can see also their name here on our product. This partner is Finder, which is, let's say, an industrial relays manufacturer and industrial components manufacturer, which is proudly in the market since almost 70 years.
Yeah, a lot. Yeah.
Yes.
They're a big player in that market.
They produce here in Italy. They really have a very, very deep experience in this type of components manufacturing, and so we are really, really proud of this cooperation with them.
Nice. We really believe that that's gonna change the way many people innovate within industrial automation. Of course, any products we're mentioning, you can find it on our store or authorized distributor worldwide. So, as Francesca, but also Marta was mentioning before, they're all connected products, right? Onboard connectivity is key for us. And everything goes to some other service we have, which is the cloud, right? The Arduino IoT cloud, also for professional.
Exactly.
Tell us something about it, please.
Yes, we just deliver in the market the Arduino Cloud for Business for all our professional customers. And what does this cloud provide? Well, it's the same really easy and user-friendly experience that we have already with our Arduino Cloud that everyone already knows, but with some advanced features for professional market. So we integrate a really great device management there, so you can manage all your devices also from remote. a fleet management system, so you can manage your fleet of devices, because imagine an industrial customer, maybe they have 1,000 boards integrated in their products, and they need to be able to monitor all of them and to be able to update also their firmware, their software from remote. And last but not least, what we provide is also a role-based access control. And what does this mean? It means that all your team can have access to your cloud, can check dashboards, can customize widgets, but each member has a specific role. You can customize what they are actually capable of doing, because maybe you don't want your customers to change your code, or you don't want your customers to, I don't know, update some widgets because you want to provide the best experience possible, no? So this is what we can provide with Arduino Cloud for Business.
Interesting. And also you mentioned the possibility to remotely update the firmware. So over-the-air updates, we know that in B2B business security is key.
Yeah.
What can you tell us about it?
Yeah, we can do this over-the-air updates in a really secure way, because we are actually leveraging the secure elements that we have embedded on all our boards. So they have this secure element that can collect all the different encryptions, they can collect the security certificates. So we are for sure able to update all their devices in a really secure way, and our customers are all really satisfied with that.
Okay, nice. So we talked about our solutions, our products, even the cloud. Let's talk about real-world applications. So there are many customers already using our solutions worldwide, but let's think about something complicated. Industrial automation, right? What pops to your mind if I say robot?
Robots. Well, everybody loves robots.
Right?
Yeah, they do. So imagine to have this NICLA vision, so the really small board that we spoke about before, on the tip of a robot. What this NICLA vision is able to do is able to detect the world around this robot, so also to detect the pieces, the goods that this robot needs to pick.
Right, so this is the eye of the robot, right?
Exactly, exactly the eye.
An
it's
intelligent
also
eye.
intelligent and connected,
Right.
also with Wi-Fi, Bluetooth, or cabling if you need it. And then what happens?
What's the brain?
Yeah, the brain can be, for instance, our Portentex 8. Because Portentex 8 with Linux can have a ROS container running.
Okay.
Yeah, and can control the full trajectory of the robot. So the NICLA vision said, okay, this is the actual good you need to pick. And it speaks with Portentex 8 that control the robot and automate it so that the robot will actually pick the specific piece. And then all of that can be fully overseen from remote with our cloud.
Nice.
And we can see, for instance, the usage trends, we can see the production line, how many goods are actually produced during that specific time slot, everything from remote.
Wow, it sounds fascinating, but we make it simple. You can do it. It's not that complicated on a technical perspective, thanks to the ecosystem we have in place, right?
Yeah.
So what else? In industrial automation, we have a lot of equipment in the production line, right?
Yeah.
Let's talk about an example of equipment application.
In fact, talking about what you can see and oversee, and also, let's say, control, one really interesting application is also predictive maintenance. And something that you can do with Opta is also actuating things, which means that thanks to some external sensors like NICLAs or any other kind of sensors that you can connect, you can, for example, detecting anomalies through temperature variances or like vibration differences from the standard. And you can elaborate them thanks to AI algorithms running on board of the Opta and detect what is happening, what is going wrong, and make an actuation, like, for example, stopping a machine that is risking to make a deviation from his path and braking.
Right, because you have a trained AI algorithm within Opta that knows how the equipment is supposed to behave, right?
You can do that,
and
exactly.
And if it's as you said, it's variating, then you react, preventing any kind of malfunction or even production line stops, right? So it's not all about production. We have a very versatile vertical markets and applications. Let's talk about building. That's a huge topic. Energy consumption and all that stuff. Home automation.
Yeah, exactly. Also with the NICLA, we can automate our home. For instance, we can build an automatic intruder detection. using, for instance, a Nikla voice.
How?
So with the Nikla voice that is really smart, it has some neural networks running on it. It is able to detect any weird sounds, for instance, glass breaking, or people speaking, but they should not speak at the time, or vibrations coming, for instance, from a door that has been opened unexpectedly. And at that point, it can communicate with a Portenta H7 that acts as like a sort of gateway and notify people, say, okay, there's a thief in your home, so you need to come back, or you need to intervene. And this is done really securely, so we are able to be there on time.
Because you have the sentience neural processor in here that is listening on the edge in an anonymous way, right? And not reacting only when recognize an event.
Exactly.
Right?
And so remaining still really low power without consuming a lot of power.
Cool.
Yeah.
Very cool. So this was safety, intruder detection. How about energy consumption?
Yeah, this is really also something in which Opta fits very well.
She loves Opta. You can see that.
That's true. That's really true. I mean, Opta can, for example, interact with an energy meter. And let's say, thanks to its connected, powerful features, we can, for example, think to actuate remotely some electrical devices that can be connected to Opta. And we can maybe also think about some, let's say, scheduled operation based on our consumption profiles that we can collect thanks to what we can gather from this conjunction of devices that we can send to our cloud, so we can make some evaluation of how much we are consuming, in which way we can get our consumption path. We can decide when and how to operate our devices to save our energy and to save our money.
Right, so we are environmental friendly, we save money, which is always nice, and we make our house smarter, right?
Absolutely.
It's very powerful, and I'm definitely eager to try that. Can you give me one in the near future?
I don't know, maybe. Let's see.
I know. So it has been a pleasure. Thank you very much, Marta and Francesca.
Thanks to you, Stefano. It was great.
So happy Arduino Day.
Enjoy all the sessions. They are going to be amazing.
And stay tuned.
Hi there. Thanks for attending Arduino Day. My name is Jason Sanders, and I'm here to give you a talk on...
Award-winning. What? Did I win awards? Maker Faire.
How to make big robots by Jason Sanders.
Yeah, that's right. So I like building robots, and I wanted to take some time to explain how to build really big robots. So like, I know probably a lot of you have built smaller robots because they're easy. At least that's what people want you to think. But big robots are easy too. So I'm going to share how I went about making a larger robot that I use to move stuff around in the yard, like mulch, and I actually ride on it. You can ride on it and move around and like different things like that. It's real big. So here I'll just kind of give you a rundown. I made some drawings. All right, so here's some general drawings that I made real quick. So first, get an Arduino. You'll need a Pi and a wheelchair base. That's right, that is actually the key to how this works. So essentially you have your wheelchair base, which I add an attachment to, that's connected to your Arduino, and it's using pulse width to communicate to the wheelchair base. I essentially tap into the joystick to hijack the joystick control, and then from there it communicates. But I took it a step further, and I'm actually using a Raspberry Pi that's powered by the batteries that are in the wheelchair. So power power to that, which the power from the Pi actually powers the Arduino, and it's also communicating it to it via USB serial. And then I can use Wi-Fi to my phone. That's supposed to be a phone. This wonderful drawing. Or Bluetooth to a joystick, which okay, here is my robot. It is a standard wheelchair base. I love these things. I actually have quite a few robots that use them. There's one there. This one here is one, all it is a platform, and it'll drive around, and that's the one that I like to put mulch on. But this is the one that I'm just going to use for the demo. So this is a analog joystick. So it has like, I think this is a, was it DB25? But I essentially patch into that. I just have like a normal patch here that I'll plug into it. Give me 1 second. Okay, so tapped into it there. It basically goes into this breakout board, which I don't expect you to see this very well in the dark, but from there, here's the board that I'm using to level out the signal. From there's the Mega, which once again I love, and then it basically goes to USB to inside here is a Raspberry Pi 3, and that is all powered by the wheelchair, which this is the charging port, which goes directly to the battery. So basically I've wired this adapter to go in the hole here, and then basically goes to this this charging jack that is the same one that you would use for like a car. This particular one is rated for 24 volts or 12 volts, which is important because the wheelchair itself runs at 24 volts. That in turn powers the Pi, which you can see it's booting up, and then that the USB cable powers the Mega. Now what I can do is I'll go ahead and because I bypassed the joystick will no longer work at this moment. I can power it up, give it some power. You see the power, it's indicating that it's working. Let's see here. Now I can start up a joystick. There, it's all powered up, and I can just kind of move it around. Now I am using Node Red on this particular robot for the Pi. So it also has the ability to use a little web app to like run around and stuff. And that can be controlled from anywhere. It's just standard, like web protocols and stuff. If you guys have any questions or anything, you can always reach out to me at jasonsbigrobots@jasonsanders.com. You can check out my website. I'll probably put a little something about this out there, just to kind of give you some more information, because it was a little quick. All right, so build some big old robots. Tap into these old wheelchair bases. They work fantastic. Check it out. It's nice and cool.
Over the year, humans have evolved in inventing new technologies for reducing human efforts and saving human rights. Hello, my name is Judy Osama Hussein. I'm 10 years old. I'm in grade 4.
Technological advancement is at its peak. Every sphere of life is cubed with a high tech. Hello, my name is Iran Muhammad Abdurrahman.
This project presents the design and implementation of a prototype personal assistant robot, PAR.
An intelligent machine can assist and interact with a person in a smart manner. This advancement makes crystal clear that future are going to be highly tech-lit.
This robot consists from 2 servo motors, Arduino Uno, and cardboard. When green flag click, turn on video on stage with zero transparency, forever show bounding box, analyze image camera, say class of object 1 from 0.5 seconds. If it is person detected, then set servo motor 5 to 0 angle. Set servo on 6 to 0 angle. Else set servo on 6 to 90. Set servo on 5 to 90 angle.
And we're back. How cute were they? This actually ties us into the next part where, by popular demand, we have 2 of our favorite presenters back, Roxana and Melissa, who will show us how school life can be easier with the Internet of Things, thanks with our AG Vision Arduino Day special. So it's always great to involve students from a very young age in all of these technology. And as our final community project, we will have Milos with his Orb Weaver Rover 2 project. He has designed and made a semi-automatic robot platform optimized also for 3D printing, and he has used a hardware controller using the Arduino Mega and also a Raspberry Pi 4. And just before we go on to our presentations, we want to say a very special thank you to our community. Thank you so much for sharing and taking part with us and showing your projects to the world. Don't forget to stay tuned afterwards as well. We have some thrilling Arduino announcements for you guys and some keynotes directly from Chicago. So enjoy and thank you again.
Hello everyone, and happy birthday Arduino. This is EduVision Arduino Day 2023 special. We hope that you have enjoyed the Arduino Day events and speakers so far. I'm Melissa, and with me,
Roxana from Arduino Education, and today we're going to talk about teaching IoT for tomorrow's innovators.
Yes, and learning about IoT requires students to understand the combination of hardware, software, and programming languages.
Most of all, using IoT allows a student to tackle real-world problems, making them better problem solvers and critical thinkers. IoT also offers plenty of jobs in part because it's not only an industry or a specific technology, but it's a compendium of all of this.
Yeah, and next we will see how the White Mountains Regional High School in the US used the Arduino Cloud and Arduino IoT Cloud to build an automated greenhouse. The aim of this project was to automatically take care of the plants that the students grow throughout the year. So let's see the video.
Students at White Mountains Regional High School in New Hampshire, United States, have built an automated greenhouse in a project that has come together across disciplines, including computer technology, environmental and sustainability, and mechanics and fabrication. Students have used the Internet of Things, the cloud, and Arduino to connect their learning to the real world by building a working prototype of an industrial-scale automated greenhouse.
Right, as the digital landscape's evolving, right, we're seeing more and more of these smart devices, right, in our homes, in our places of work, right, our places of business, And there's no reason why students shouldn't be exposed to them in their schools. The students should actually have the experience of working with these devices and understanding how they work and what they can be used for. But students, in terms of what they actually have to know, right, in terms of barrier to entry is very low, because all they have to know is how to interface with the Arduino device, and they can get things quickly up and running. So they had a beautiful cloud interface where they were able to set up and design a thing, create the variables that they wanted to go to the cloud and go back to the device.
IoT has made coding a lot easier for the newer generation. Back then you'd have to do all the hard coding yourself, but now part of it's done for you. So it's a lot easier for new people to get into it.
So for this project, we hooked up this table with the IoT device. What you see taped to the windows there are our light sensors, and then we can have the watering control, we can have additional daylight for the plants to grow. There's a temperature sensor on the wall that is controlling the fan.
So I originally started out with programming the light system, so the lights would turn on at a certain light level outside.
I worked on the watering system and the moisture, just making it so they can turn on automatically and turn off automatically.
I've been working on the fan, so basically it's sensing the temperature and changing it.
Not as easily, especially not sharing it. Like we shared it around the world, and if we didn't, we wouldn't be able to do that if it wasn't part of the internet and the cloud.
Without the Arduino cloud, we'd have to set up a web server. Arduino, that's just right there.
It is important to me that my students walk away both with content, real-world experience, and then some soft skills, so that they can apply those soft skills to any job, any career. Those are something that you need to build throughout life, and that's what really sets you apart usually from others in the workplace. You know, can you be a critical thinker? Can you be an independent learner, but a collaborator?
These students are well on their way to learning both the soft skills and STEM skills they need to succeed in the real world. Get started with the IoT and cloud-based learning with Arduino Education.
To create projects, students at the White Mountain Regional High School use the Arduino Cloud and the Explore IoT Kit.
Yeah, let us show. We have a blog post about it here. So school's environmental and sustainability instructor Aidan Howe recommended that in a project like this, students out of the textbook and they're doing this hands-on and something that's meaningful.
Students are being able to ask questions, to engage, to do some background research, to have an idea that you want to test out and find the answer to be able to collect the data, communicate that data, talk to peers, and then communicate the results to an outside audience.
With the Arduino Explore IoT Kit, high school students can create their own connected devices quickly and easily. And I actually have the kit here with me, so we can show it. So, yeah. So here. So the kit comes with the Maker Wi-Fi tandem board that I have here. And you put it together with the Maker IoT carrier. When you take the carrier and the board from the kit, you connect them together, and then you just plug the power. So I have the USB connected to my computer here. And we have already uploaded a sketch to the board. So this one comes together with the kit. So when you take the board for the first time, you can start playing with it immediately. So this one allows to try out all the different we get to try all the different sensors, get to know our carrier. So here, for example, to move my hand.
Also, we have created 10 sustainability projects that allow students to investigate and solve real-world challenges linked to the one of the UN's Sustainability Development Goals. These projects equip students with scientific and design thinking methodologies to study sustainability issues using data analysis, and build solutions using advanced IoT systems.
Yes, and together with the hardware and the lessons, we use the Arduino Cloud. So the Arduino Cloud allows us to create IoT project with hardware. It allows us to code with hardware, access exclusive lessons and activities, and manage students, teachers, and admin roles. Let me share my screen to show it to you guys here. So to get started, we go to the cloud.arduino.cc, and I have logged in with my Arduino account, and this is what I see. So this is the home page of Cloud.
Mm-hmm.
And we have really thought about teachers. So this is a one space that you need to create everything. So you have one space for everything. You have members, you can add and remove students from here. You have all the resources, courses, all the tools that you need, everything. So here you can add students, add a member. You have all the resources here, all the different tutorials, courses. With the school plan, you get also exclusive projects, activities, and lessons.
So as you can see, all the resources that educators need are in one place. So it's very convenient because you don't need to look for other places to get all the resources or materials you need to run hardware, IoT projects with your students in the classroom.
Yes, and then if we look at the IoT Cloud that also the White Mountains Regional High School used.
Yes.
So here you can see I have the same space that I had in the Arduino Cloud, and all this space, everything that I share in this space is also visible for the students that I have included in this space. So it's really convenient. You don't have to do some separate sharing. You can have everything here.
Exactly.
And here you can see I've added some variables. And if you have the school plan, you get unlimited variables. So you can add as many as you want. And with that, you can create really interesting dashboards. So we can have multiple different variables here. We have moisture. We can have a pump, turn it on and off, for example.
Yep. You can personalize your own dashboard. So that's very interesting. And also what is very interesting is the fact that we can visualize data using this dashboard. So it's very good that students can see what they are getting from different sensors.
Yes, and we don't have to take it to a separate Excel sheet or spreadsheet. We can all do it all here.
Exactly.
And since this IoT Cloud is also making it easier for us, it generates code automatically for us, so we don't have to create everything ourselves.
Yep.
We can see it from here. But what I think is really cool that we can still access, we can see the code and we can modify it. So if we want to create something more complex or want to add stuff, we can have the chance to do it.
Exactly. So it's very user-friendly if you are new to IoT, or if you're a little bit more advanced, you can make yourself your own by modifying it with the web editor. So it's super useful.
And we have also, this is a thing that many people don't know, but you can add actually pictures and report and everything to the sketch that you have in web editor. So now I added a worksheet, and this would be my assignment, for example, for my students. So then I decide to share it to my students using the Google Classroom. So if you have the school plan for Arduino Cloud for Education, you have also the Google Classroom integration.
Yeah. So as we said, Arduino Cloud for Education collects all the tools in one space: web editor, IoT Cloud, resources, lessons, assignment, and classroom management.
And if you would like to learn more about the Arduino Cloud for Education, and especially the Arduino IoT Cloud, you can join our free webinar in April. So more info is coming soon on our social media channels. And if you don't already, you should subscribe to our educators newsletter so you get all the latest news.
Exactly. All of the new developments on the cloud, we're going to inform there. So subscribe and stay tuned.
Yeah, and I can tell you that there are a lot of new widgets
Yes.
coming, cool ones, especially for educators, for education, really useful ones with graphs, and you can see different variables to track their correlation and everything.
Yeah, it would be so great, so don't miss that out.
Yeah. So thank you for joining, and hopefully we see you in our next webinar.
Thank you. Happy Arduino Day.
Bye.
Bye.
Hi, welcome to my video for Arduino Week 2023. My name is Miloš, I'm an electrical engineer from Serbia, currently pursuing a master's degree with my main focus being on robotics, as you can see from this guy here. I work part-time as a hardware engineer working on new PCB designs or just trying to troubleshoot some old PCB designs. In my spare time I work on my projects, as you can see again by this guy here, or as you can see by some equipment that I'll show later on. In this video we're gonna be filming in my home lab, as obviously you can tell by all of the tools in the background as well as all of the other test equipment here. I started with Arduino around 8 years ago. Back in 2015 the first Arduino I ever bought was an Arduino Uno starter kit. I managed to find a single store in Serbia that actually had them in stock, and I was thrilled when I managed to turn on and off the LED for the first time. Since then I've done countless electronics projects, and a lot of them actually use an Arduino since it can be really easily integrated into them. So let's get started. Before I get to the main topic of this video that's sitting next to me, or better said parked next to me, I'm gonna show you some of my older Arduino projects first. First, for example, let's look at my constant current load. What's a constant current load? It's a great piece of test equipment that you can actually make rather easily using just analog components, or you can put maybe an Arduino into the mix as I did. What it does is that you can actually program it to draw constant current from a power source. That can be really useful when you're testing out circuits, power electronics, batteries and stuff like that. I used an Arduino Nano 33 IoT in this device because it has integrated DAC, which was really easy to integrate with the rest of the electronics in this build. And it proved to be rather reliable and a really useful piece of test equipment. Another project that I did was this drone that hasn't flown in a while, as you can see by the motor not being attached. It actually used 3 Arduinos. One Arduino Nano was in the RC transmitter, one was in the RC receiver that was on the drone, and the last Arduino that you can still see here is the flight controller. This is a project I did about 2 years ago, and I actually got it flying pretty good, but since I want to change a lot of stuff on it, as on most of my projects, it's still kind of a work in progress that I wish to visit again. Now let's get to the main topic of this video, this rover right here. This is the Orb Weaver Rover 2. It's highly inspired by the NASA rovers like the Curiosity or the Perseverance. This was my diploma project actually. This is the project I had to complete to get my bachelor's degree. The goal of this project was to make a robotics platform that I can easily work on, add sensors, actuators, and generally work with path finding, path planning algorithms, SLAM, and stuff like that. Let's look at some key features of this rover. First of all, it has 4-wheel steering, as you can see by the servo motors on top of the wheels. Every wheel also has a drive motor inside, with a custom designed 3D printed gearbox. The gearbox has an additional reduction of 1 to 10, which means that the torque increases tenfold. Another thing that we can see here are the wheels. You will see all of the parts of the wheels shortly, but just to explain the principle behind the wheels is that each of these PLA printed parts actually acts as a spring. Because there's no shock absorbers anywhere else on the rover, they actually work as shock absorbers, and you can see that they're actually quite flexible, and by varying the thickness of the those spokes, you can actually make harder or softer springs. Now, the core component of the rover that actually inspired me to build the rover is actually a mechanical part of the NASA rovers, and that's the suspension. The NASA rovers use something that's called a rocker bogie suspension. What it does is that if this wheel, for example, lifts 20 degrees, the body will lift only 10 degrees. So that all of the angles that can actually affect the body are halved. As you can see here, this works in the same way, but the same principle, but it uses some different components. Instead of a rocker here, it actually uses a differential underneath, but that actually allowed me to add a servo motor, which can actually automatically adjust the level of the rover so it's always stable. But as you can see here, even with the motor turned off, if I lift the wheel this high, that the body of the rover only did half the angle. Another thing of the rover that we can also see is the mast and the head. The head has 2 degrees of freedom, as you can see. Here's where the Raspberry Pi camera should be, and on top we also have a 360-degree LiDAR. That's actually really useful for SLAM and stuff like that. That's something I want to combine with the 2 degrees of freedom of the head and to do some more exotic algorithms, let's say. So let's take a look at how all of the internals on the rover work. I'll now go through the 3D model and show you all of the things I showed you on the rover itself, but sub-assembly by sub-assembly. We'll first start with the head and neck assembly, and we'll first look at the pitch axis of the rover. It's also a geared reduction, and we are using a servo motor that has position feedback. As for the yaw assembly, we can see that we're using the same servo, and we're using a different gearing so we can get a 360-degree rotation. Now we're going to look at the wheel assembly. The steering servo is a standard servo with just 180 degrees, and that's something I plan on changing. This is how the wheel is made. It's made from a PVC pipe and all of the 3D printed parts that I already showed you. Now we're going to look at the spokes that I talked to you about, and depending on the thickness we can vary how stiff the springs themselves are. Now we go to the gearbox and motor assembly. The motor that I'm using already has a planetary gearbox, but it needed more torque, so I added a 2-step gear reduction that reduces the speed by 10, so it increases the torque by 10. Suspension differential is the key component of the whole rover, as I already said, and it's the one thing that was highly inspired by the NASA rovers, that whole differential suspension style. So first let's look at some pictures of how the actual differential looks. Here you can see it printed out of multiple PLAs and attached to 2020 extrusions, and here is how the whole system works. So the servo motor you can see on the left, it's a continuous servo motor, but it wasn't strong enough, so I had to add a 2-stage gear reduction, which you can see on the here, first stage and second stage, the blue-green and the white-green gears, and the differential itself, it's actually only the red gears in the center. Here is how I added those gears after actually trying out and seeing that the motor doesn't have enough torque, but it all worked out in the end. It was a bit of a tight squeeze to get everything into one package, but thankfully it all worked out in the end. And here in the end we have the differential that you can see with the beveled gears, and for the rods I just used M8 threaded rods with 8mm bearings. This is something that maybe I can improve on a bit to have less slack in the system. The electronics on the rover can be separated into 3 categories: the power electronics, the Raspberry Pi electronics, and the Arduino electronics. I'll concentrate on the Arduino electronics, of course, but just briefly, power electronics include the LiPo battery, the relays, the fuses, while the Raspberry Pi electronics include literally the Raspberry Pi, its power supply, and its connection to the IMU and the Arduino. So let's look at the Arduino electronics now. Arduino is used as a hardware controller in the rover, so Raspberry is running ROS on it, doing all of the algorithms, and all of the actuation is actually done through the Arduino. So Arduino controls 7 servo motors, 2 L298 and motor drivers, which are controlling the 4 driving motors. So here we can see the schematic of everything that's connected, and here we can see the picture of all of the electronics without the Arduino. And as mentioned before, the rover is still a work in progress, but I managed to conduct some tests. Here you can see the rover turning its wheels first to 0, then to 180 degrees. This means that the rover can actually move from side to side freely. This was actually from when I was defending my bachelor degree project. And for the final test, of course, I wanted to drive the rover a bit. So here is the rover driving. You can see the stop in the mechanism when the rover starts, and you'll also see it when it stops. That's the M8 threaded rod thing I talked about that I plan on fixing in the next version. Thanks for watching. Hope you enjoyed learning about my rover project. If you have any comments or questions, leave them down below and I'll make sure to answer them. It's still a work in progress project, so as soon as I get it to a satisfactory level, I'll make sure to publish all of the CAD models and all of the code for it. So stay tuned. Bye!
Introducing the new Arduino Make Your Uno kit, your one-stop solution to learn soldering and programming that will guide you to assemble your very own Uno board.
With Arduino's open source hardware and software, you'll be able to make a complete project from scratch and create a very personal audio synthesizer.
No fear, if you haven't soldered a piece of electronics before, the kit experience will include everything you'll need to create a perfectly functioning Arduino microcontroller.
No soldering skills are required, and we'll instruct you via a step-by-step guide on how to solder to perfection.
Program your way to a fully functioning audio synth and unleash your knowledge and creativity for new and exciting projects.
Hello everybody! Today I'm here to introduce you to the Make Your Own Uno kit, the new electronic experience made with Arduino. Have you never soldered before? With this kit, it will be super simple. Learn how to solder, learn how to assemble your board, and you'll build your first audio synth. Do you know what the craziest thing is? That you'll make it play. Don't wait. Go back to the future with Arduino Make Your Uno kit.
Welcome back, and wow, wasn't Milos's rover impressive? I can't wait to see the final designs when he has finished that. Really good piece of kit. Really should say a big thank you to all the members of the community who have shared their experiences with us today, because we're about to cross over live to Chicago, where Fabio and Massimo have some really exciting news to share with you all and give you a sneak peek of what's to come from Arduino in the coming months. So over to Fabio and the team in Chicago, and enjoy the rest of the presentation.
Hello everyone. Good morning, good afternoon, good night, depending on the place in the world where you are. It's an exciting day. We are today streaming live from Chicago. We are at the Hem Hub, basically the temple of creativity for the Midwest, but probably one of the best places to be in the world, where you see a lot of machines behind me, and makers are doing stuff and creating ideas that basically will become soon companies or are already companies. So it's amazing because it's in line with our strategy and philosophy at Arduino. And without further ado, maybe we can go to our keynote presentation. That basically it's more kind of a, let's say, a summary of the day, because you saw a lot of technology and a lot of ideas, a lot of people, community presentations. So what can I say at the end of a day like this? I'm just excited to be the CEO of a company that is changing the world one piece at a time. So I wanted to share with you some numbers, first of all, because our community is thriving, is growing all the time. We have more than 30 million people actively developing on Arduino in the world. We have 1.1 million people on the forum that are actively asking and answering questions. We have a lot of visitors on the online store. And very importantly, we also have a ton of people in the cloud right now that are using our services, our web editor, our IoT cloud, etc. So regarding the numbers, I think there is nothing that can be compared to Arduino and the enthusiasm of our community. So a big thank you to all of you for our following also on all the social channels. Regarding innovation, when I took this position at Arduino, we discussed a lot with the co-founders and in particular with Massimo about what shall we do in terms of strategy. And we decided that the only way to be an important company and an important community was to innovate by putting a lot of energy and resources into the R&D part. And this is what we have done since day one. One of the results of the efforts that we have made is the release of the Arduino ID 2.x. That is a tool that is widely used across the globe that required a little bit of a upgrade. It was a huge upgrade for us, a big investment. And I'm really thankful to all the people, not only within Arduino that contributing to the development of this product, but also all the people in the community that are contributing by providing feedback, by providing localization efforts, and so on and so forth. As you can see from this quick chart, the ID 2.0 took off very rapidly, and we reached 14 million downloads since we launched it a few months ago. As you can see from this chart, the Java ID is slowing down, but the new ID is taking over, and it's becoming ubiquitous and deployed on many computers of all our users. And one of the key features is also for this product is the possibility to connect it to our cloud so that you can seamlessly work online and offline with the product. So very proud about this innovation. Talking about cloud, it's also skyrocketing in terms of usage. As you can see, this is the number of messages in the last 12 months per week. So we went from 300 to 800 million messages per week managed by the cloud. This means that a lot of people are connecting their devices, their connected device, Arduino, but not only Arduino devices, because the cloud can work also with third-party technology and API. So we are really proud about this development. We are putting a lot of energies. You will see a lot of innovation here. And of course, what we have done last year was to deliver 3 incarnations of the cloud, one for makers, one for educators that find it very useful to speed up the process of teaching in the cloud, and also for enterprise customers. The latest incarnation was for enterprise customers, and there is a lot of innovation coming there. Of course, we are committed to open source. We released a lot of official material on open source, and one of the most important thing is the official cores. We had 13 new releases of official cores for not only the traditional AVR, Mega AVR, SAMD, but we added RP2040, we added STM32, we added Nordic and RF52, and a lot more is coming. And we also released a new version of the Arduino Core API abstraction layer. Regarding the community, we are really proud to have this thriving community. We had 24% more new libraries. So it's a big jump. So we now reached 5,500 more or less libraries based on Arduino. And more importantly, these libraries are alive and they're continuously updated by the community. So we had more than 5,000 new versions of the libraries in 2022. We also had a lot of interaction on GitHub. That is the place where our developers exchange ideas and exchange pull requests and exchange innovation. So again, more than 6,000 new interactions on the GitHub repositories. But of course, we cannot work and do things alone. So we expanded our ecosystem of partnerships. So as you can see on this chart, I will not comment each and every one of them, but we created a number of new partnerships in the space of development tools and the software SaaS, in the AI space, where we reinforced some of the partnerships that we had, and we created new partnerships. And silicon vendors, of course, they are the basis of all the technology that we delivered. And we expanded as well the partnership ecosystem, as well as a number of co-branded partnership opportunities with a number of companies that you see listed here. So a big thank you to all these partnership. But of course, this partnership is continuously evolving. So one of the latest partnerships that we signed is with Renesas, that we are really proud of having as a new partner for us. And we also created a stronger relationship with Espressif, a partnership relationship with Espressif, not only on the pure hardware technology, but we are working with them to deliver more innovation for the community, and very new things will be coming and will be announced in the upcoming months. So regarding the AI, a special mention goes to Edge Impulse. We are working very closely with our friends there, and it's amazing how much we are delivering together, not only in terms of technology, but also in terms of spreading the word about embedded AI, AI on the edge. And we also integrated their tools in the Arduino IoT cloud. And it is really a fantastic collaboration in a very important area where we can make our devices more clever and able to take decisions on the edge. Regarding partnership, there is also a special partnership that you will see a specific video on. On this is a partnership with a fashion brand called Keyway, together with Edge Impulse and Arduino. But I don't want to spoil too much about this. You will see a lot more on this partnership, and how important it is to involve not only the community but also the enterprise ecosystem into some sensitive topic for the society. Regarding the strategy, we didn't change too much compared to what we said last time. So the focus of Arduino has always been to develop our community, but we are also being very close to two other areas. One is the education part, because we strongly believe that education is at the basis of everything. And we created 3 business units that you see here listed. One is dedicated to education, the other one is dedicated to the general maker community, and the last one, in order of time, is Arduino Pro, that has the aim of taking our products not only for prototyping, for the prototyping stage where we are very popular, but also for production. So we released a number of products in the Arduino Pro family that go into this direction of enabling companies to scale with Arduino and not having to redesign based on individual components. So regarding the biggest transformation of Arduino that we are implementing one step at a time, we have the basically Arduino what we call the Arduino platform, with the 3 incarnation of Makers, Education, and Pro, where we basically started from the lower level of hardware and accessories, so building block to create innovation. Then we are actively developing cloud and on-premises tools for developing on top of our hardware. And we added the IoT AI platform in the cloud, trying to get value from your devices. So this is very important, and we are pursuing these objectives continuously, and we are developing to provide a sort of end-to-end open environment for our community. So this end-to-end unique offering is made of hardware, is made of development tools, is made of cloud, and more importantly, is made of knowledge. And we are not the only contributor to knowledge, thanks to the large community we have, because you can find information on how to adopt electronics, how to learn to program, how to solve complex problems, and also there is huge components of self-help help provided by the other members of the community to solve all the difficult obstacles that you may find during this journey. Regarding the core board evolution, there was a quantum leap in terms of processing power and capacity of our device. So I will not go into the details because it's a huge family. The latest addition, for example, for the Makers product was the Giga that we just released a few weeks ago. And the Giga is a very powerful product that inherited a lot of the expertise that we developed for the professional market with the Portenta family, with the Nikla family. And as you can see in the top right hand of the screen, the Portenta X8 is also a crossover product. We basically merge microcontroller and microprocessor into a very powerful industrial product that can be used as a system or module for sophisticated applications. But it is not all. So there is a lot we are doing. For example, you just saw the advertisement of the Make Your Uno kit. This is a kit that goes into the direction of helping people learn how to solder their products, but with a specific goal. So it's not just an important experience, but it's also a funny experience, because basically you end up building your own Uno and your own Uno shield that you can play with crazy sound coming out of it. A little bit annoying sometimes with the high frequency, but it's very, very nice experience. But beyond the single boards, what we learned by talking to our enterprise customers is that sometimes in order to have a short time to value in their projects, they prefer to have more finished products that can be programmed using the Arduino language, or programmed using the traditional technology, for example, traditional PLC languages, complemented by Arduino libraries. And that's one example that you see here today, available on the market, and has been a tremendous success. Hopefully, the supply chain allows us to manufacture the quantities that the market is requiring, but very, very warm adoption by the community, also by the industrial community. It's a partnership with a company that has been doing devices in the building automation and industrial devices for forever, and we combine the power of Arduino technology and board design with the solidity and high quality design of a company that has been there working on rugged environments. So regarding another evolution of the platform, so Arduino, it's important as a language, but we are also looking at the mega trend in our industry. And Python and MicroPython are very important for edge development, for development in general. So we're really serious about MicroPython, and we released a initial editor for MicroPython that we call Arduino Lab for MicroPython. You can go online and download it at the link that you see there. And we also made an important partnership with micropython.org to release official ports of the Arduino boards. That's very important because we are contributing to the open source community as much as we can. Regarding probably the most awaited moment of the day, at least I hope this is the important announcement today. I would like to call Massimo here with me. Ciao, Massimo.
Hey,
welcome.
Ciao.
So
I am photobombing the. No, we were. So I'm really happy to be here. Hi everyone. We're live in Chicago. It's true, and
yes.
And yeah. So we're talking about. You see what you see on the screen. It's a blog post from 2010 that describes the launch of the first Arduino Uno at Maker Faire in New York. And I think this was of all the experimentations that we did in Arduino, this is when Arduino became a real product. I would say before it was a bit, experimental. This is a stable product. We launched the new website, we launched the new logo, we launched the pack. So everything became real that day.
So Massimo, by the way, with this product, so I know that you are very modest, but at the end of the day, you transform the world with this product, at least our world. So, and of course, all products, are very important, and they have a history. And today, what we are basically announcing is the evolution of that product to take into account all the new possibility that all the silicon that is available today gives us. And we are announcing the Arduino Uno R4. That is basically the product you see here with a little bit of mystery still.
Yeah.
So there will be upcoming, announcement in the next weeks.
What is underneath the box?
I cannot disclose it, otherwise, Alessandro and the team will kill me. Okay. Anyway, so this is a product where basically are combining multiple innovation. So first of all, we are using a new microcontroller that in this case will be a Renesas microcontroller, but still 5 volts operating voltage. It's a 32-bit Cortex M4. And in the Wi-Fi version that you saw before, we are using the Espressif S3 Wi-Fi in addition to the main microcontroller. So very powerful product, but we designed it for maximum compatibility to the Uno R4. So not only the voltage, but we did a lot of testing, and we are also doing a lot of work with the community to adapt and evolve their libraries. After my presentation, there is a presentation from Alessandro Ranellucci for early adopter program to facilitate the porting of some of the libraries that may be relevant for the community that needs a little bit of tweaks and adaptation to work perfectly with this new product. So I think this is very, very important also in terms of other characteristics that we are providing to our community. So basically we increased the size of RAM from 2 kilobytes to 32 kilobytes, the flash memory from 32 to 256. We evolved the USB. One of the biggest complaints from the community was that we were stuck with the old connector. Now we have the USB-C. And also the supply voltage has been raised to 24 volts to enable many more applications. We provide CAN bus and SPI ports, and also it's very new. The board has also a 12-bit analog digital analog converter. So it's very, very powerful technology, and I hope you will enjoy this product. So it will be available late May, hopefully supply chain permitting, but to be notified when the product becomes available, the best thing to do is to go to the link provided here and subscribe for the updates. So I think this is a very, very important step for us and for our community, and I hope this will unleash more creativity from all our community members and will enable new application, especially with the combo Wi-Fi and microcontroller version, where you can connect it to our cloud or third-party cloud, create your own MQTT-based application, and create very new things, also based on your existing ecosystem of shields, pieces and parts and accessories you may have in your trays. So it's a very important announcement. I'm really proud that we are sort of starting to wrap up the day with an important announcement. Give us your feedback on the social, give us your feedback ideas, and let us know what you think. So I hope I'm on time, more or less. So thank you very much for your attention today, and I will introduce now Alessandro Ranellucci that will talk to you about this early adopter program that is very important. So join the program and enjoy the rest of the day that is almost going to be closed in a few minutes. Thank you very much.
Hello and happy Arduino Day! And this is a very special Arduino Day indeed, because we announced something big. Did you miss the announcement? We announced the Uno R4. Exactly, we are upgrading the most iconic Arduino board. And I have one here in my hands. So I have something to tell you. As you heard, this new board has a Renesas RA4 microcontroller. It's a very powerful microcontroller that we chose because it's super robust, it tolerates any kind of mistake, and it also runs at 5 volts. This means that, from an electrical point of view, any project made for Uno R3 will also work on Uno R4. And this is super important, because beginners can take an existing tutorial and they can use it regardless of which board they are using. However, on the software side, compatibility sometimes can be trickier. You know, most projects will just work out of the box because the Arduino language is universal. However, some libraries often are optimized to use low-level functions of a specific architecture. Libraries like motor controllers, LED strip controllers, they need sometimes to be adapted to each new architecture. So here is the announcement for you. We are launching today the Early Access Program. If you are the author of an Arduino library or the author of a popular open source project running on Arduino, we are giving you the possibility to get a free Uno R4 before the public release. This way you can test your code, you can adapt it if needed. We will provide you with documentation and a direct channel for technical support. Go check the website. This is called Early Access Program. See the link, read the instructions, fill the form, tell us who you are, what library you wrote, and you will get an Uno R4 for your tests. Remember, this is not for everyone, so if you're not a library developer, keep your curiosity because the board will be available in a few months from now. This is just for the maintainers of Arduino libraries or open source projects running on Arduino. If you are not a library developer, remember that many library developers accept your support in terms of donations, so don't forget to support open source all the time. This is all from my side. Goodbye!
Hi, everyone. Welcome back from Chicago. So we're almost drawing to a close of this day. Basically, we are have one last video, and then afterwards we're going to show you a little bit the space where we are here in Chicago. We're going to introduce you to some new people who have recently joined Arduino here in the US, but I'm not going to spoil too much. So right now, there's a very nice video that I shot with my friend Alessandro Grande from Edge Impulse. So, it has been mentioned before, but basically we started this project with this iconic Italian brand of jackets called Keyway. And together with Edge Impulse, we ran this competition to who could build the most interesting TinyML plus Arduino Nikola Sense plus Keyway jacket. And the competition went really well. There was a bunch of people that applied. They made a lot of projects. So we selected about 10, 12 projects from the one that people completed. And you can find all of these projects on Project Hub. Basically, you can, in this video, you will see me and Alessandro go through every project, comment the project, and then basically describe the winner, or winners of the competition. And then we will, these people will receive a small prize from Arduino as a thank you for participating. We ask all the people to share the project live on Project Hub. So all these projects that people have built, and you will see in this video, are available for you right now on Project Hub to download, to look at, to learn, to study, to try, to build. So I hope you're gonna love this project the same way that we loved making it. And without further ado, the video, and I'll see you later for the goodbyes. Hi, everyone. This is Massimo Banzi from Arduino with Alessandro Grande from Edge Impulse.
Hi, everyone.
And so we're here today to talk about a project that we have organized quite a few months ago. Arduino partnered with this company called Keyway, which is an iconic brand of rain jacket and a bunch of other types of jackets. Originally invented in France, but it's an Italian brand. And we wanted to combine our hardware, the Nikola Sense ME, which is this little box that you can see here next to the jacket that contains a lot of sensors. And when we wanted to organize a competition to see what happens if you have technology embedded in a jacket, what can you do if the jacket has all these sensors and these capabilities? Obviously, we understood that machine learning was going to be an important part. So we invited Edge Impulse to take part in this, help us organize this competition. Okay, Alessandro, can you tell us what Edge Impulse is?
Yes, absolutely. So thank you, Massimo, for having us. Edge Impulse is a development platform for machine learning. And it's exciting to have helped throughout this competition it's really about empowering engineers to build machine learning that can do real things, right? That can really help in real situations. So this was a great idea or a great opportunity to put machine learning to work and actually turn, normal jackets or normal things that we use every day into something more clever and intelligent, right? So that's what we do, and that's what we've done together. So thank you, Massimo.
No, obviously, we have been, Arduino and Edge Impulse have been working together for quite a while. Also, the Edge Impulse platform is available within the Arduino Cloud platform. So if you are a user of the Arduino Cloud platform, you will find Edge Impulse as one of the tools that you can use. So you can go to their website or you go to our website. So the process was we manufactured this device, the Arduino Nicla Sense ME, which is a tiny board the size of a postage stamp. It's barely 1 inch by 1 inch in size. And then we developed a plastic casing, battery, a way to kind of connect the object to the jacket. And then we manufactured a bunch of them, and we dedicated 40 of them for people who applied. And we sent these kits. And then people built projects. They sent us back their proposals, and we selected a short list of the project that we see here now that we are going to show you very quickly. So we're going to describe very quickly the projects and sort of what they are about. And then, me and Alessandro will pick one project that we think represents well this competition. So something that has been probably built and it's like a fully built application that could be used in a real life scenario, but I don't want to spoil anything. And let's get going. The first project I wanted to show you is this interesting project from the user that on the Arduino platform, Toolmaker Alchemist. And so we are using the new Project Hub platform that Arduino recently developed as an evolution of the previous iteration of the platform that was originally developed by Hackster.io, and now we developed our own version. So this competition is the first competition that we run on the new platform. But apart from this project to me is interesting because it describes potential use of this technology and tiny machine learning for sort of interactive art. I found that it was interesting that someone thought about using TinyML as a way to build tools for performances for art. So I thought this was clearly something that should go into our shortlist.
I think just to add to what you said, I think it's always interesting to think about technology as a way of interacting with the world, right? So I think in that sense, this project was really interesting as an idea of having something on you that allows you to interact with the world around you in a better way, right?
I agree with you. And so, congratulations to Toolmaker Alchemist for this project. Second project in the shortlist is called the SAJAC, and it's a smart jacket for caving. And it's interesting because essentially it turns the E-Way jacket into a tool that an explorer can use inside the cave to monitor their situation and basically relay data back to a device. There's temperatures, humidity, air pressure, air quality, gases that you need to monitor. So I think it's interesting because this person also developed this idea that you have a device connected via LoRa outside the cave that can watch the data coming from the person.
This was really good. I mean, as you said, it was really well built. I think there was a lot of documentation. I mean, the person built a full app and this full system to effectively alert people rescuing or watching over the team in the cave.
Yeah, also one of the things that's nice about this project is that we asked people to document step by step how to rebuild the project. So anyone who's interested in this kind of stuff can actually go and follow the instruction, download the software. Obviously you need the Nicla, but then you can actually build the project and test it. Second project, actually no, sorry, this is the third project. Whoops. It's another project that has to do with cave exploration from the user SACP. And again, this person mounted the Nikola on a helmet, wearing a jacket, and it's using an Android smartphone connected to the device. You can start to see here, he collected some data about the activity that the person was doing. So you can see here, he's trying to detect if the person is crawling, is idle, is upstairs, downstairs, walking. So it's using the sensor to detect the activity that the person is doing.
Really, really interesting project. One thing that, from a machine learning perspective, one thing that's interesting is that if you look at exactly the diagram before this, actually, Massimo, so you can see here, this is the model that has been trained. By looking at this, it looks like the data points used for training are actually less than the data points used for validation, for testing. Typically, the way to build good models is to have 80% of the data in the a part of that in the validation set, and then only 20% in the training set. When you're building machine learning models, you should always think about the data as the first thing you should optimize.
No, that actually makes a lot of sense. But I want to congratulate also this user for building this project that has a very clear use case, is potentially useful to the people. Next project. So this one is a quite interesting project. It's called NSME Assistant with Blue Universe. They built an application for mobile phones that connects via Bluetooth to the device using App Inventor. So did you look into this project a little bit more?
Yeah, so it's interesting. I mean, I think I agree with you. Like the interesting thing here is that they used a low-code tool to build an application, right? And that's obviously it's very kind of similar to what we do at Edge Impulse and what Arduino does as well. So we all have like simple interfaces to build things, right? And I think this App Inventor is a good addition to that toolbox. To build a full application. They've collected 11 minutes of data of different types, but they haven't actually had the time to build more. But it's an interesting application.
Congratulations to the user for developing this project. Let's skip to the other one. So this one is another interesting one. So this user, called CareIG, on the platform, created a device to detect mushrooms. It's essentially some kind of a stick that you can use to kind of detect the smell of mushrooms.
Sorry, no, I was just going to say that the idea in itself is really interesting, right? Because one thing that is really hard is to recognize mushrooms that are, potentially harmful, right? And I think having something that can help you to understand from the smell whether the mushroom is a mushroom you can eat or not, I think is super interesting as a concept.
So you can see here, he collected 39 minutes of data, which is interesting. Yeah. So he has a different kind. This is the ambient air, and this is the air while near this boletus type mushroom. One of the things that I didn't mention at the beginning is that this Nikola Sense ME from Arduino contains a very sophisticated sensor from Bosch, Sensor Tech, which has the ability to detect certain kind of gases like CO2 and volatile compounds in the air. But you can actually train the device to actually sense other smells of gases. So you will find projects where people have trained the sensor to understand the smell of cheese, the smell of coffee, or to detect if a drink had alcohol or not. So it is a very, very high potential sensor. So this is a nice project. So congratulations to the user. Next project. This project is quite nice. Do you want to describe this project?
Yeah, so this was an interesting project. What hit me at first is, this was a project built by a dad and a daughter together. They actually built this project to detect odd odors let's say, body odors, right? So the idea was, can we detect when we need to shower, right? So they actually went on a run, right? And they managed to collect data from them after the run or before the run. And then they used machine learning to detect the difference in smell, right? Or in odors or in gases. Yeah, they actually collected 41 minutes of data here. So pretty good. The other interesting thing here is that they also used an anomaly detector block, right? That's interesting. It basically detects whether there is anything that is different from the two things that you've trained it for, right? So you've trained it to recognize two different classes. If I smell something completely different, right, rather than trying to match with one of those two classes, can I say, actually, this is too far off, so it's an anomaly, right?
Congratulations to this duo of Luke and Elena, of father and daughter, who worked on this project. It's absolutely hilarious, but also quite interesting in a way, no? So we are getting to the end of the list. The next project is very interesting. It's a project that is trying to detect diabetic ketoacidosis, which is something that happens to people who have type 1 diabetes and is potentially life-threatening. And the breath of a person who is going through this, from what I understand, I'm not a doctor, but the breath has compounds that are similar to acetone. So what the user did, they collected a bunch of data. The user is also saying, I'm not a doctor, this is not a medical device, it's a proof of concept just to try out. So he's basically putting all the data into the edge impulse system. And here you can see all the data he collected and all the different level of warning. I mean, I think personally that something like this, it's a very interesting direction. In the future, if someone had a device that you could just blow into from your jacket and tells you you are sick, it's probably one of the directions where technologies we work on. It's where TinyML can really give a contribution to the world.
And I think this is where the partnership with Arduino is really, really important, right? Because you can buy this device, right? Like it's a device that you can get from Arduino, and you can go to this project that this user Yamanou's Rai has done, and you can evolve this project. So you could potentially just clone the project and then develop your own version of this. Anybody can go and make this better, right?
Yeah, I think you hit on a very important point. This idea that both the Edge Impulse project and the Arduino code, it's in Project Hub. So these tools are designed with similar philosophy, this idea that you encourage people to share the results of their work so that other people can build upon. And so I think that's I think captures very well the Arduino spirit. Project is very interesting. Don't use it as a medical device because it's not properly tested. But the concept is great. So the last two projects, I have to say the last two projects have some similarities between them. So the first one is from this user. It's called Timothy. He made this project, a smart jacket for fall detection. So the idea is in the description of this project, it talks about a lot this concept of human activity recognition, HAR, which is actually as part of the work that people do in machine learning, to try to use sensor to understand what kind of activity a person is doing. Edge Impulse can do this extremely, extremely well. No? So in a way, it's important to have these tools. He's imagining a situation where the sensor is using Bluetooth, the gateway could be a smartphone, and the data goes to a cloud system where healthcare or even just a relative can figure out that the person has fallen down. And you can see here in the Edge Impulse platform, he has different captures of what the sensor sees when you're falling versus when you're just walking.
I think one thing we haven't said is why machine learning in these cases? Like why would people use machine learning, right? You could do this by hand, right? You could write logic that describes exactly the difference between these signals, right? But the challenge with that is that, first of all, it might take you your whole life. I mean, these are simple signals, but it's a hard problem, right? It's not an easy problem. And then the other thing is, what happens if the activity changes a little bit? You train the model to do a certain thing, but then it hasn't learned to generalize enough so that it recognizes differences, right? And so that's where ML can really come to hand, right? Is expand your capabilities to do things that are slightly harder to do by hand.
So congratulations to Timothy for doing this project. Again, the project is available here. Here you can see all the data and the model. And actually at the end, you can even go to deployment. You click on Arduino library and you get an Arduino library that implements exactly the model, which in my opinion, it's the power of the Edge Impulse platform that literally with a few clicks, you can get to meaningful results. So the last project is in a way similar, is from Christopher Mendes, and it's called the Protector Life-Saving Wearable. And it's still doing activity tracker with configurable alerts, AI powerful detection, and then also does air quality monitoring. One thing that I found really nice about this project is that the kind of detail that went into building this thing, because this user, he built a mobile app. This is the mobile app is built that lets you visualize the data. And then you see on the activity says on a vehicle. So it's also already decoding the kind of activity that someone is doing. So it's their air.
And you can actually download the app as well. So he's gone the full way. He's actually deployed the app on Android.
This user went through the whole process of actually doing it for real. No? So it's the most thoroughly implemented idea. And over here, you can see the Edge Impulse project. So you can see here the data acquisition. So this is what happens when someone is falling, when someone is still, these are the sensors, walking. And this is the model he created. It seems like a nice project, no?
This is very well built. I mean, he's gone far beyond what our expectations were in the sense that he's actually built a full, I mean, I was impressed to see full working application. So that's pretty impressive.
What's also interesting from an Edge Impulse user perspective is that this person created an application running on an ESP32 device, which bridges between the Bluetooth and the Edge Impulse cloud. So you are able to collect the data with 10 hertz of resolution. And I think this is a nice tool that might be useful to any Edge Impulse user who has a Bluetooth device and wants to load the data onto a cloud while being on the field. So congrats to this user for also developing this tool. Should we, reveal our preferences?
So I would say my two favorites, the one that we talked about earlier about the ketoacidosis, right? Because I think it's a really interesting concept. And I think the idea of exploring things that could be used for medical reasons, I think is super interesting. Knowing that our tools could be used for improving lives is super interesting. And by the way, there are companies out there building these things for real, right? So this is possible. This is just a proof of concept, but things like this could actually be built with these technologies, right? So the other one, it was the last one that we went on, the Protector. I think that was, we talked about it a lot. It was very well built, full application, interesting idea. And as you said, he also went beyond just building the application itself. He also built a kind of additional tool that could be used by others.
So I think I agree with you. Actually, for me, there are these two and a special mention. Let's put it this way. For me, the one about the diabetes, the idea is powerful. So from a concept perspective, that wins. From an implementation perspective, the Protector wins. And special mention, the smelling fresh, feeling fresh, to me gets a special mention because it's a nice idea. It's actually even a little bit funny, but also it's a father and daughter team, so it's quite, it's quite something. So we will communicate this on the website. We will basically send the prize to these three users. So best implementation, best concept, and a special mention of the jury. So, well, thank you very much for commenting these projects with me, and thank you very much for participating in this project.
Thank you so much. It was really awesome, and thank you all for participating, and thank you for watching. Big congrats to everybody that managed to build something, right? I think that's the most important thing.
Yeah. So thank you to Alessandro and Gimpus for the help on this project. Thank you to Keyway for being our partner in this project. Yeah, thanks for all the people who participated in the project and built something and submitted. We love you all. So thank you very much, and I'll see you at our next collaboration project competition. Thank you very much. Bye-bye.
Bye.
We're live. Hi, everyone. Welcome from Chicago. Can you hear me? Can you hear me say something? Well, anyway, if you can't hear me, it's okay anyway. So we're here in Chicago. We're going to say goodbye, but I just wanted to show you a little piece of the stuff that's going on here. So I'm going to grab the phone and show you a little bit what's going on here. We have a nice group of people showing different projects. And yeah, so we got Kat here making lamps. Say hi to the audience. Ciao, audience. And yeah, so we got people making educational tools, and the Fred here making a system to scan film and slides. Say hi to the world. Okay, cool. So we're gonna grab some people and then say, hey, look at that! I didn't see you. Sorry, so our friend Bold Engineer. That's your artist name. Yeah. Bold Engineer. So we got a group of people here. So I wanted to introduce also to another couple of people. Let me see. Okay, sorry. So this is Fabio Violante. He's the CEO of Arduino. He flew here to be with us today. Thank you, Fabio. Well, he just gave a streaming talk in the other room. So you can see it's not fake. He was actually here physically. So I want to introduce you to another couple of people, because this year we've been expanding our presence in the US, and we have an office in the US that's building up. So I wanted to introduce to Gunit Bedi, who is going to be heading the US office of Arduino. Say hello to the community.
Hi, everybody. I'm really excited and looking forward to it. And we'll be building offices in Austin, Chicago, East Coast. So yeah, looking forward to it, expanding and growing.
So you can see this man around the US promoting the Arduino gospel.
Yes.
And this is Ben from Chicago, who is one of the people running the office in the US.
Yes. Hello, hello. Some of you guys already know me. I'm Ben Strahan. The people that don't know me, I'm really hoping to meet you. I'll be all over the world, but mostly in the US. So please connect and share the projects that you have going on. Yes. Thank you.
Perfect. So should we all? We have to say goodbye to the.
Let's all say goodbye to everyone. Come on into the picture.
This is closing 4 hours and 10 minutes of streaming. Some people have been actually watching 4 hours of streaming, so they're probably dying right now. So thank you very much to all the people that showed up here, to all the people that went through 4 hours and 11 minutes of streaming, and all the volunteers. I also want to thank the Arduino marketing team who worked on this thing, and also Keith Jackson and Aurora Gould, who are also our presenters. Sylvia, right there, who did a ton of work, and she's still alive. And then, and also Anna and Lucrezia, who are behind the scenes doing the streaming from Switzerland. And we also have volunteers here. We have, also say hi. Thank you very much. So, it was great. This is the 10th edition of Arduino Day. And so we're very happy to be here. We also want to give a special thank to M-Hub, which is this amazing place in Chicago that has hosted us. And we've been here almost, for a good part of this week. So thank you very much for the hem up stuff, and everyone was like super nice to us. And just say wave goodbye, and Lugano, you can disconnect us. We're done. We are waiting for the cake now. Go away. Ciao. Ooh, bam.